Trust you can all hear me.
Yep.
Okay.
Hi, Rick.
Morning.
Well, depends on where you are.
I'm in God's country.
Yeah, well, so they say.
Oh, you'd think it's the other fellow with the temperatures we have too.
Yeah. Okay.
I have a cat that I think is going to photobomb us here shortly.
Could be worse. I like cats. That's why I send you some of those things.
Yeah, I got 5 of them. Had 10 2 years ago, but nature took its course.
My cat's here, Pumpkin.
We've got a dog, a dappled Dachshund. And I like dogs. I like your dog and your dog and your dog. I didn't want a dog because when you go out of town, you got to put him up someplace. Well, here we are. He's 18. And according to the vet, that puts him at 120. He's a good dog. But now he's deaf and pert near blind. He can see light and dark, and that's about it. I feel bad for him, but where it goes. We had cats. I've had cats.
This meeting is being recorded.
And then there's Greg Shanos. Hi, Greg.
Hi,
Where are you located, Greg?
who's that speaking?
This is Ken O'Shudley.
I'm in Florida.
Oh, so it's not hot enough up here in Atlanta.
It's pretty hot with the heat index, yeah.
Yeah. Where are you at in Florida?
Sarasota.
Mhm. Good.
But amazingly, the seeing is very steady. Seeing's very good overall in the morning.
Hey, good morning and afternoon, everybody.
Morning, afternoon, you two.
We're still, more people are joining us as we speak, so we'll wait a couple minutes.
Got 26 already.
Yeah, and I got 8 on YouTube.
Oh, okay. 34 then.
Yeah.
Hey, Richard.
Yes.
Hey, tilt your camera down a little bit. We only see the top half of your. Okay, that's better.
Better? Okay.
Morning, Keith.
Good morning, everyone.
Morning.
Good morning.
Now there is the man in the moon if I ever saw him. He's our eclipse guy, eclipsing the moon. Now, if you move back and forth, Keith, that would be a transit, right?
It's 10 o'clock. We'll wait a couple more minutes for a few more stragglers to come on.
10 o'clock Pacific time, which
10
is
o'clock Pacific time, right?
one
Yeah.
UT.
It's 17 UT.
17, yeah. 'Cause
Hello, everyone. Everybody hear me?
yes, Frank.
Yes, sir.
Hey, Frank.
Okay. All right.
Hey, Frank.
There's John Nagel from Baton Rouge. Hey, John.
Yes. Hello?
Is that you, John?
Yes.
Yeah, I think I talked with you in the past. My wife is from the other side of the Atchafalaya. I call it the swamp. She's from Lafayette.
Right. I believe we have before.
I heard they're putting speed sensors on the Atchafalaya Bridge on both ends. I read that the speed limit is 60, and they're going to actually watch the cars on these with these sensors. And if you get across the bridge in anything less than 18 minutes, because it's an 18-mile long bridge, you will be getting a ticket.
Wow.
That's correct on that. The speed limit for cars is 60, trucks is 55. Trucks are limited to the right-hand lane only, supposedly, unless passing. But they said if it's more than 8, if you get across the bridge in less than 18 minutes, you will get a ticket in the mail. And the word now is that they're going to start putting cameras like that up on all types of roads all over the state now.
There you go. Well, we'll be down
I'll
there at
tell you what.
Thanksgiving. We'll be down there at
I've
Thanksgiving.
I've seen people hitting 60, 70, even 80 on occasion on that bridge. And 2-lane bridge with only 4 exits and 18 miles, that's way too fast to go on it.
That's right. That's right.
Years ago, I read about a thing over in Texas. I think it was on I-45 between Houston and Dallas. They put 9 radar speed traps 1 mile apart from each other on the same side of the road.
Wow.
So if you missed one, you get hit by another one. You think if you got hit, okay, it's safe. So you kick it back up again, you get hit by the second one. When you hit the third time out of those 9, they said, that's it. Lock the car, give me the keys. We're taking you in.
Wow.
All right, everybody. I'd like to get started. Those of you that don't know me, I'm Tim Robertson. I was one of the many that put this conference together for everybody. We have a few simple rules we're going to go over before we get started. Number 1, keep yourself muted during the presentation. So if everyone right now just put themselves on mute, I'd really appreciate it. That includes you, Ken. Thank you. For Zoom during the conference, if you have questions, use the chat function to ask your questions. And we're going to try to hold off on all the questions till after the presentations. On YouTube, those of you there, we have 9 of them over there on YouTube right now. Use the comment section to ask questions. I'll be monitoring that during the day. Obviously, I don't need to tell all of you to be professional and courteous at all times, and failure to follow these rules will get you booted from this meeting. Do we have any questions on that? Everybody understands those rules very simply, right?
What do you think we're looking at? What's our attendance like so far?
Right now, we have 32 on Zoom and 10 on YouTube. And what I'd like to ask everybody to do, we started this conference with 300 subscribers to our YouTube channel. I'd like to get it to 400 at the end of tomorrow. So if you have not subscribed yet to the YouTube channel, please do so. I'd really appreciate it. The more subscribers we have, the more people come to the channel, and the channel is also going to be changing quite a bit in the next few months. It currently has a lot of our podcasts on it, and this, like I said, this event is being streamed live on it as well. So I would really appreciate those of you that could head over there and please subscribe. And now to get started, I'd like to introduce the director of the ALPO, the one and only Carl Hergerother. Carl.
Thanks, Tim. And good morning, good afternoon, depending on where you are in the world. I'd like to thank everyone who's attending, including those who maybe aren't here watching in real time, but will be watching later on the YouTube podcast that Tim was just talking about. And I'd like to thank everyone who actually makes the ALPO happen, from members to people who contribute observations, and of course, all the volunteers who volunteer their scarce time to run the sections, produce the journal, organize this meeting, outreach, everything that makes the ALPO go. As I'm sure everyone's well aware, especially if you see the logo there in the upper right, this is the 75th anniversary of the ALPO. It was formed back in 1947 by Walter Haas. And if we go back to the very first issue of the Strolling Astronomer, which came out, was dated March 1st, 1947, the very first article you'll see in that first issue was from Walter, and it was simply titled An Appeal. And I'll just read a little bit from it. There exist amateur astronomers. There exist the telescopes they have built. There exists the moon and the planets. This leaflet, the Strolling Astronomer, was only about 9-10 pages at the time. This leaflet is an attempt to persuade the party of the first part to use the party of the second part to increase knowledge of the party of the third part. It's kind of a common refrain that you even hear nowadays of, we know there are a lot of people interested in planetary astronomy. Some of those people have telescopes. Mind you, 1947, most people were building their telescopes. Now most of us buy telescopes, so things have changed a little bit. But even of those people who have telescopes, some of us even use our telescopes. And some of us, when we use our telescopes, observe the planets. So if you are making observations of the planets or comets or anything in the solar system, and to be honest, even objects in other solar systems external to our own, as our new exoplanet section is concentrating on, remember to send your observations into the ALPO. It really helps. It helps the organization, and it helps increase science. I'm often asked, when I go and I solicit observations from various people, mainly for the comet section, since I'm the comet section coordinator, I'm usually asked two questions from people who are maybe a little hesitant to contribute observations. One is, they kind of ask, how do my observations actually further science? Considering nowadays, it seems like we have spacecraft either in orbit or flying by all of the major planets and many of the minor ones as well. Is there anything that observations from my backyard can actually contribute to our understanding of these objects? And two, what if a lot of people feel their observations aren't good enough? So they always ask, well, what if my observations aren't good enough? Do you still want these observations? And just to answer that second question, all observations are important. Yes, there are different levels of, I don't want to say quality, but not all of us, live in places with perfect seeing or have giant telescopes or have kind of mastered, the art of astrophotography or planetary imaging. But all observations are important because they all they all contribute to monitoring these bodies, whether they're the planets, comets, meteor showers, whatever, and making sure we have constant coverage of these objects. And it's very possible that your observation, even if it maybe is through poor seeing or cirrusy skies or whatever, maybe the only observation that shows a particular phenomenon that was only observable for a short amount of time. So all observations are really important. And then as for furthering science, it's interesting because if you look back, okay, 1947 is when the ALPO was created. In 1947, to put it mildly, planetary astronomy was neglected. It just was not a priority. There were very few people interested in it. The solar system, we had figured it out. Everyone was now doing redshifts and cosmology and galaxies and quasars, and the big telescopes were being used for that sort of thing. So it's very interesting when you go read those first couple of years, or even first few decades of the strolling astronomer and the ALPO, seeing the names of people who were members of the ALPO in high school or as undergrad at the time, who would then go on to become luminaries and giants within the field of planetary astronomy, which by the dawn of the space age, and especially with the United States placing people on the moon, all of a sudden planetary astronomy came back in vogue. But nowadays we're still in the middle of what you probably call the golden age of astronomy, planetary astronomy, and for the very reason I mentioned before. We have spacecraft everywhere. Pretty much every major body, and even a lot of the minor comets and asteroids have spacecraft that are going by them. And the thing is, not all of these spacecraft can monitor the full object at all times. One of the most recent launches and developments, of course, is the James Webb Telescope. And we saw the images, the first 5 images that were released last week. Everyone may not be aware that even though it wasn't part of that first release, and I'm not sure why, but it was publicly released, was pictures taken of Jupiter. They actually used Jupiter to do some of their initial testing, mostly scattered light testing. So these wonderful images in the near infrared, high resolution, so in Jupiter's rings and all those sort of things. But we as amateurs who are constantly monitoring the solar system and the planets actually can play a major part in helping the James Webb science team. The James Webb has a bunch of different observing projects that have been accepted. They're pretty much going to be observing all of the major planets, with the exception, unfortunately, of Mercury and Venus, because unfortunately, James Webb can't point that close to the sun. But from Mars on out, even Pluto, including quite a few of the comets and asteroids, James Webb will be observing all these bodies at some point over the next couple of years. But there's one dedicated program in particular I want to call out, and it's titled Extreme Events on Gas Giants, Impacts and Storm Eruptions. And this is what they call a Target of Opportunity program, where basically if an asteroid impact, doesn't have to be Shoemaker-Levy 9 size, but we know objects have been observed impacting Jupiter. If an impact is detected, as well as a major storm eruption like the ones we have seen on Saturn in recent years, if one of those were to occur, James Webb would very quickly, in the order of hours to days, be pivoted to observe either Jupiter or Saturn to observe these events. And the thing is, chances are it will be an amateur astronomer, most likely from their backyard, using a telescope from their backyard, who will be the first one to detect these objects. And it's possible someone actually on this call or listening to this conference later on will be the person who identifies that impact or identifies that new storm erupting on Saturn, which will then result in the $10 billion James Webb Telescope being pointed at it and really studying and increasing our understanding of these events and these bodies. So even though, yes, we've got spacecraft everywhere, it's still the backyard observer who, and in most cases, the amateur observer, who's kind of the early warning system for detecting changes in the solar system. So when you wonder, are we still contributing to science? Yes, we are. And I kept us on schedule for first talk.
Oh, very good. Thanks, Carl. I have one question I just want to get out there that someone has asked. Let's see. John Nagel asked, will there be pins, patches, or decals with the 75th anniversary logo? That's a great question. And in our board meeting tonight, we'll discuss that. How's that sound? All right. I think with that, Ken, I think you are doing the introductions for the talks. Ken?
You're muted, Ken.
Somebody make a sign they can hold up that says muted.
I just asked him to unmute.
Okay, I want to ask Tim if he could spend a couple seconds while I pull up my bios.
Oh, now you're muted, Tim.
Okay. All right. Okay, here we go. Our first speaker of the day is Matthew Will. Matt joined the ALPO as a dues paying member in 1973, which was a great year, I guess, for me. He has been serving as the ALPO's membership secretary since 2001. And he lives in Springfield, Illinois. For those of you, I'm going to be mentioning this for all of the speakers to give you all an idea of how spread out we are. That is in central Illinois in Springfield. And his topic, let's see here, is going to be, what's my membership number? A Strong Astronomer's Guide to ALPO Membership. And that'll include a short introduction about the ALPO. And he'll answer some of the most frequently asked questions from ALPO members. So this time I will just turn it over to Matt.
Okay, well, thank you, Ken. Let me get it up here. And trying to, well, let me get out of that. There we go. I will go ahead and just go ahead and go to the share screen first and click on that, and then click on slideshow here. And there we go. Okay. I hope everyone can see that. I had to pull the curtains aside there. Okay. Anyway, my presentation, I decided to take a little bit of a different departure today from the usual the usual standard approach. Usually I talk about how to become an ALPO or ALPO member. And so rather than just preaching to the converted this year, I thought I'd also spend the second half of this presentation actually answering some common questions and misunderstood issues about the ALPO or ALPO. And of course, I'm a little bit old fashioned. I prefer to use the letter name as opposed to the mnemonic, but anyway, either way is fine. But first, let me introduce to our guests, especially those out on the YouTube channel that are being familiar with ALPO for the first time, what we really are. And I want to give one warning about this presentation. This presentation is only an invitation to join the ALPO, and no one should feel coerced in joining our organization. There are no prompts or subliminal messages in this presentation to persuade anyone to join the organization. You're free to join us if you want. But upon examining recent issues of our journal in the galleries portion of our webpage, you might feel a sudden urge to want to read more. Reading the journal can be addictive, and we take no responsibility for any obsessive compulsive behavior. I just want to make that clear. Incidentally, our webpage for back issues, which anyone can peruse, is located below the URL. And all I can say is good luck with that. The ALPO is an astronomical organization dedicated to the study of solar system bodies. And I think Carl beautifully outlined what we do. And of course, we're amateur based, and our sections and programs are ran by amateurs. And we do print time with those coordinators for those sections and programs do analyses and do have them published in our quarterly journal. And our data, incidentally, is also used by professional researchers too, observations, data, et cetera. And our coordinators also provide guidance, training, and feedback to the interested amateur that participates in these observing programs. In contrast, today and tomorrow, you'll have a unique opportunity to actually see and hear a number of wide-ranging presentations about various topics of solar system astronomy given by our talented volunteer staff. And they will range from observing techniques involving photometry and even historical observing techniques involving solar observing to presentations covering topics involving the moon, planets, and comets. And you'll have a chance to actually interact with our speakers through our question and answer session involving their presentations immediately after they give their presentations. So don't also forget that we do have our board meeting Friday evening. So in addition to having 2 daytime sessions of paper sessions Saturday, Friday and Saturday afternoon, we have the board meeting Friday evening, and we also have our keynote speaker to speak after our awards presentations. The noted Lunar Authority Charles Wood has been kind enough to do a presentation of his own about lunar impact basins. And of course, don't forget that we're going to have door prizes given away during these 2 days of conferences. So if you're registered through Zoom, you should be able to be automatically registered for the door prizes. The ALPO, I try to talk about the ALPO in terms of a working model. And so you'll see the term ALPO model. When I gave a presentation last year, I talked about the 4 dimensions of the ALPO. I talked about our observing sections and programs, and that the data and observations that are used are fed into our 2nd dimension, which is our journal. We also have as a side venue these conferences I talked about earlier. The ALPO will be hosting its 73rd meeting in 75 years. We actually held our first meeting in 1956 as a joint conference between the WAA, Western Amateur Astronomers, and the ALPO in Flagstaff, Arizona. The reason for the odd count in conferences is that from the late 50s through the 1960s, there were some years where we had 2 conferences over the summer so that it could meet both with the WAA and the Astronomical League, but we've gotten away from that simply because it's just too much work to try to supply speakers for 2 conferences. Our last 3 have been virtual, and we hope to go back to having in-person conferences someday. The ALPO website, you could think of that as our 3rd dimension. The website has freely available material to get the observer started and informed about late-breaking transient events occurring anywhere in the solar system. The gallery section, which is separate from the section and program web pages, has uploaded observations made by ALPO observers. These collections, some of them go back to very early times. Some of our coordinators have observations going back nearly 75 years. Jim Tomey, our hardworking assistant coordinator for the online section, is working with other ALPO staff to revamp the ALPO website and make it more presentable and more user-friendly. And he's going to be doing a presentation later on today, going into detail on how that's being done. The ALPO also realizes that amateur astronomers are not necessarily born but raised. And so our 4th dimension, the outreach section, knows that and is doing a number of new and advanced things to promote the ALPO and lunar and planetary astronomy. The training program has been around for more than 70 years and offers paid ALPO members a chance to actually advance their observing skills through the tutelage of the program coordinator, Tim Robertson, and upgrading their visual drawing skills as well as their ability to properly document observations. The youth program managed by Pamela Shivek currently reaches out to youth and youth-related programs in science and astronomy, giving them opportunities to participate in ALPO observational astronomy in general with the ALPO. And this is being done principally through social media. However, we may have even a more expansive venture into dealing with youth as time goes on. The ALPO podcast are also another part of our outreach section. And these have been very successful. They've been going on for about 5 years. And this gives a chance for ALPO staff and special guests to have the airtime to discuss their sections, programs, or other interest. And you might be viewing this presentation today along with others through our YouTube channel. This channel is set up to offer members and non-members alike a chance to view video interviews, cover special events live, as well as recording them for playback later. And our overall outreach section coordinator, Tim Robertson, will speak about the outreach section later today and some ambitious future projects that are planned out for that section. The ALPO has seen great expansion in the last few years in these sections and observing programs, with growth of our outreach section, improvements in formatting the ALPO website, and granting greater access and ease to the digital journal for our paid members. The ALPO recently created a board of trustees to oversee the growth of the ALPO endowment. While the principal purpose of the ALPO endowment is to provide support for a future central office one day, it can be used as the engine for providing additional revenue to ALPO operations, including the journal. And while the ALPO endowment is currently too small to provide financial support right now for the ALPO, trustees can oversee its growth through wise investing, fundraising, and possible grants in the future. For now, in the meantime, the ALPO is dependent on revenue from its members principally. We get some revenue from advertisements we run in the journal and purchases of hard copy back issues. But while members receive the hard copy journal pay for its production, members receiving our digital journal also pay for our other costs as an organization. So your membership dollars do support our existence in so many ways. And we are grateful for those members that can support us at higher membership levels too. We really do need the money. And here's the sales pitch. ALPO membership is relatively inexpensive compared to a lot of other organizations. We offer a one-year membership for the digital journal only at only $18. You get 4 issues of the journal over that year period. If you pay for the paper journal or pay for 2-year memberships, the dues rates are a little higher. You can check out our membership plans, and you can also pay by check or online. For more information, consult our ALPO website at the URL listed. I will give more information on how to join the ALPO a little bit later on for paying a dues-paying membership at the end of this presentation. What are the memberships of ALPO membership? Well, I've already told you about the journal which you get in basically 2 formats. One can also seek training if they're a paid ALPO member through the training program. And there are other benefits at higher level memberships that we offer in our literature for these types of memberships. If you pay at the patron level or above, you'll get free access to hard copy back issues. At the benefactor level or above, you would be entitled to a free book published by an ALPO section coordinator through a professional publisher. Your membership dollars, whether you pay at the basic regular rate or at a higher level membership, support our operations as well as the journal and are sincerely appreciated. Well, what are the advantages of using the digital journal versus the paper journal? Well, if you receive the digital journal, we have complete color in that journal, whereas the hard copy issue is only printed in black and white with a color cover. The printing cost for color right now are just a little too high for us to cover. However, that's still being looked into, and it's still a possibility that we could do a complete color issue of the ALPO on a regular basis in the future. But we're very cost conscious about keeping the memberships affordable. Also, the digital journal has one additional important feature that the paper journal doesn't have, and those are embedded links in the articles and in their references at the end of each article. You can click on those links and go directly to the source material that the author used. And also, members that get the digital journal will get it weeks in advance of the hard copy. And that's we're not putting a fault at the U.S. Postal Service. We have chosen to mail at the periodic rate, which is a bit slower than first class, again, to keep the cost of membership down. Well, you're probably wondering, well, what's my membership number and what is it used for? Well, your membership number, along with your current email address that we have on file, is used to download the digital journal on a web page that only paid ALPO members have access to. You can reference your membership number in 3 ways. First of all, the acknowledgement letter for first-time purchases and renewals. We do have the membership number listed on there, along with the email address that we have for record for you, and also that membership number should be on your membership card, which is also enclosed with the acknowledgement in the lower left-hand corner of your membership card. Also, you'll get that number on your introductory email for all first-time members. We try to answer membership purchases from first-time members within about 48 hours of getting the receipt. And so we try to get you up and running as soon as possible. Of course, if all else fails, you can always contact me at my email address at matt.will@alpo-astronomy.org, and I'll be happy to shoot you an email back, reply, and give you your membership number that way. And of course, how do I know if my membership expires? I get frequent emails about this. And of course, again, check your acknowledgement letter. The expiration is also on the membership card, generally the same place as the membership number. And also, if you receive the hard copy journal, your expiration will be on the mailing label at the top above your address. And you can also contact me again by email, and I'll be happy to let you know what your expiration is and whether or not your membership is truly expired or not. Expired memberships expire with an issue or are not officially linked with a term or time limit. So 1 year means you get 4 issues, and you will get 4 issues even if we do fall behind in publication. But we haven't really fallen behind in our publication schedule in 15 years, thanks to our very efficient publications section coordinator, Ken Pashedley. Well, the ALPO also sends renewal notices via email and an early bird renewal notice in the postal mail before a membership expiration occurs. And those receiving the hard copy will also receive additional hard copy renewal notices inserted with the issues that they get, give those members an extra chance to renew. And I get this question once in a while. How do I download your blah, 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 blah journal from our website? Fix the problem. There are a number of things that you can do to resolve downloading at your end. First of all, be sure that your browser has been updated and that you're using the latest version of that browser. You should download using virtually any kind of a browser. Likewise, update your Adobe Reader software that you're going to be reading the PDF version of this digital journal. You need version 7.0 or higher to read the journal. I think Adobe Reader anymore will proactively update, but you should really be aware that that could be an issue. Also, some people have had problems just downloading material from our web page. It's a section, such things as section periodicals or other materials. And some browsers don't like the split screen approach that we have to our website. And so the best way to get around that is to get rid of the banner at the top. And you could do that by clicking at the lower half frame that has a content portion and selecting a menu of options, view only this frame. That will allow the content frame to fill up the screen, and the banner will disappear, and you're able to download anything off our website more effectively that way. And finally, I get this question occasionally: how did the Strolling Astronomer get its name? Well, the typist that helped Walter Haas, our founder, construct that first issue of the Strolling Astronomer back in 1947, then a part-time writer and secretary Eugene Foster suggested the name to Walter as they were completing construction of that issue. In her early years, Eugene taught elementary school and was a secretary for the United States Treasury Department. Her love of marketing and advertising moved her into a 40-year executive career with advertising agencies in New York City, Albuquerque, where she probably met Walter, Denver, and San Francisco, specializing in copywriting for all media, layout, typography, graphics, and print production, including editing and publication. So Eugene was kind of a kindred spirit of kins in a way. Eugene passed away in 2009 at the age of 96. One year just shy of Walter's age of 97. And of course, I think her epitaph on the tombstone is quite fitting: an inspiration to us all. And she was certainly, maybe, possibly an inspiration to Walter as well. And so the ALPO has endured for 75 years due to a dedicated multitudes of observers, those seriously interested in the study of the solar system and its bodies and phenomena, and those that have kindly supported us, not only in interest, but also financial support as well. Let's continue to support the ALPO at these levels and beyond. We're already reaching people in multifaceted ways, being relevant to the times. The ALPO, I'm sure, can endure for another 75 years. And I just want to conclude this talk by giving a special thanks to Rachel Hubel for designing our 75th anniversary logo. She's the daughter of Jerry Hubel, who is also our exoplanets section coordinator. Thanks a lot, Rachel. And with that, I'll answer any questions I didn't cover in the presentation.
Matt, I got a question real quickly, because I know we want to stay on time here. Two things. For those of you that don't know, the ALPO Journal is the only tangible thing that membership gets.
Well, I would also say the training program is too.
Training program as well, that's true. The other question is, do we offer any kind of subscription discount, or are we able to get that from Astronomy Magazine and Sky and Telescope Magazine?
Well, this is the thing right now. We're very affordable at $18 for the digital membership, and we're $45 for the paper, and know that we can really lower our memberships really much lower than that. And I think if you're talking about possibly getting a break from Sky and Telescope or Astronomy Magazine and
Yes.
subscriptions, I think that's what you're really getting at. You know, we really aren't a local astronomy club. I think local astronomy clubs offer that service already. I think we'd just be overlapping. I would suggest, if you want a discount, to do that through your local astronomy club.
Hey, Matt.
Yeah.
Well, there's a question in the chat from Frank. Do we have any access to professional journals?
That's something I really, I would say in a word, no. Now, I know that when John was editor of the journal, he was accepting some professional publications, or at least reciprocal amateur publications, and I don't know whatever happened to that. I'm talking about John Westfall, who was our editor between 1985 and 2001. And that's something maybe that might be worth looking into, is seeing if we can get into some kind of a reciprocal relationship. One of the problems is, since we don't have a central office right now, I know I've been doing some retention of archival materials for the ALPO on my own. And for that one day when we might have a central office where we could keep that stored, but we don't have any really agreements that I can share with you right now.
Okay, we got a couple. We got a comment from Kim Hay. Our membership fees are quite reasonable compared to almost everyone else, the RASC and AVSO. So we're pretty good there. Jay Miller asks, "Is there a lifetime membership?"
Yes, there is. There are two ways you become a lifetime member. If you have been with us for 40 consecutive years or more, then you can become a lifetime member. We don't have very good record keeping, unfortunately, beyond before year 2000 on. We sort of have a legacy kind of record in our membership database that sort of works. But the other way is that we do have a lifetime membership for anyone that contributes $10,000. They get the journal for life that way. And there are also some benefits where we would pay for such things as your registration. We wouldn't pay for your expenses at an in-person convention, but we would pay for your registration. And the other benefits that we offer with higher level memberships would also apply to that as well. But that would be only for the paid lifetime membership. The free lifetime membership, we just do that mainly because we have a lot of people that are, a lot of members that are getting on in years, and if they've been with us for more than 40 years, sometimes that helps ease the burden of not having to pay for a membership when they're in their 70s and 80s and just have the Social Security check coming in. Well, thanks everyone for putting up with me for 25 minutes there, and for also putting up with the subliminal messages I had in the content as well.
Ken, you want to do the introduction?
Here we go. At this time, I'd like to introduce Richard W. Schmoody Jr. Now, Richard attained his PhD in physical chemistry at Texas A&M University in 1994. He is currently a professor of chemistry at Gordon State College in Barnesville, Georgia, which is, you could call it an exurb of Atlanta. It's not that close, but it's still within driving reach. So it's southwest of Atlanta. And he's got several jobs. I don't know how he does it. He is the coordinator of the Jupiter Observing Section for the ALPO. He is the coordinator of the ALPO Remote Planets Section. He is also a member of the board of our organization. He's also an assistant coordinator in the ALPO Mars section, where he specifically handles photometry and I think the word is polarimetry topics, unless there's a misspelling there. His topic today is going to be something very near and dear to his heart, as I mentioned, photometry, general photometric photometry. And in a paragraph here, photometric photometry is the measurement of brightness. This talk will focus on how one makes brightness measurements, the accuracy of those measurements and how one may use them in understanding processes taking place on planets. 3 examples are the detection of heat on the planet Mercury, monitoring dust storms on the planet Mars, and describing how Saturn's brightness changes as its rings change their orientation to the Earth. The separate ways brightness measurements are made will also be described. So at this time, I turn it over to Dr. Richard Schmude.
Thank you, Ken. All right, my talk today is just general photoelectric photometry. Now, raise your hand if you have either taken a picture of the planet or just observed it with your eye. Raise your hand. Okay, you've all done photometry if you raised your hand. Now, I've done a lot of very specific type of photometry, and I'm going to talk about the different ways to do photometry. So in the next slide, see, how do I do the next slide? Okay, there it is. Okay, I want to make some introductory remarks because I don't want to lose you right away. And then obviously we're all on the Earth, so we're going to have to deal with the Earth's atmosphere. Now, of course, something like the Hubble Space Telescope or the James Webb Space Telescope, they're going to do photometry a little differently because now those instruments don't have to worry about the atmosphere of the Earth. I want to talk a little bit about the method or different methods, and then finally we'll wrap up with talking about some applications. All right, now in the next slide, photometry is basically the measurement of brightness. Now, the beauty of photometry is you can use different filters. You can use a red filter, a blue filter, or even a near-infrared filter. You can use some light that even our eyes are not sensitive to. Now, hold up 2 fingers, everyone. 2 fingers, everyone. Okay, there's really 2 broad types of photometry. The first one you probably are familiar with is disk integrated photometry. Basically, you're taking one brightness measurement of an entire object. For example, last November or last May. Anyone remember last May 15, 16? What happened there? What did we have last May 15th? I'll give you a hint. Look at Keith Spring's background. Okay, we had an eclipse of the moon, right? I was able to take disk integrated brightness measurements, and I was measure the entire brightness of the moon. All right, but then there's also disk resolved photometry. That's where you're measuring individual features. For example, Christophe Pellier has recently been able to do this with the planet Uranus, measuring the brightness of just the north polar hood and then the rest of the disk. And this is where I think the future is for the ALPO and the British Astronomical Association and similar organizations. And this is a whole area that is virtually untapped. It's this disk resolved photometry. And I want you to kind of think about that, okay? Especially you people who have digital cameras. All right, in the next slide, there's really many different ways of doing photometry. Probably the simplest way is just use your eye. And the ALPO does not do this much, but the Association of American Variable Star Observers still carry out eyeball estimates. The accuracy is about 30% or 0.3 stellar magnetism. By the way, the magnitude is the unit of measurement for brightness when it comes to astronomy. And of course, there's a way to convert that to other units. I don't want to go into that right now, but it's possible. Now, photoelectric photometry, that's where you use an instrument and you take a brightness reading of the entire object, for example, the planet Jupiter. Typical accuracy, about 2%. Oh, you're right, Carl. We do use eyeball photometry for comets. You're right on that. Now, probably the most accurate way is to use a CCD camera. And the reason why is you can get a comparison star in the same field of view as your target. You got them right next to each other. Accuracy of 0.5%, maybe even better. I mean, I know with the exoplanets people, they can get down to 0.1% accuracy. So again, I might even be a little high on that number. And then finally, very recently, Christophe Pellier over in France and even professional astronomer in Arizona have used spectra. They've collected absolute or accurate spectra, and then they go back and integrate over, say, the V filter passband, and they're able to compute a V filter magnitude from the spectrum. Okay, so again, these are just 4 of the different ways of carrying out photometry. You can also use photographic photometry, but it's really not as accurate as, say, photoelectric photometry. Right, now, if you're going to carry out measurements from the Earth, you have to really do 2 calibrations. Hold up 2 fingers, everyone. Come on, 2 fingers. There's 2 things you have to calibrate. Now let's go to the next slide. First off, let me ask you a question. Is the full moon brighter near the horizon or overhead? Anyone? Full moon brighter over the horizon or near the, or overhead or near the horizon?
Overhead.
Overhead, definitely. And that's because the atmosphere absorbs light. And the moon is probably could be it could be a factor of 30 or 40 times dimmer if it's just a couple of degrees above the horizon compared to when it's overhead. And that's because, again, our atmosphere absorbs light. And for the same reason, that's why the sun does not appear as bright when it's near the horizon as it does when it is near the zenith. So again, that correction has to be carried out. Now for CCD images, you probably don't need to carry out extinction corrections unless you're imaging, say, Mercury near the horizon. Now there's a second big correction, and that is differences in color sensitivity. All right, let me ask you again, once again, raise your hand if you own a refractor. If you own a refractor, raise your hand. All right, how about some kind of Newtonian telescope? Raise your hand. Okay, now a Newtonian has a different color sensitivity than a refractor. Of course, one of the problems with the refractors, you get sort of some of that bluing, I think. Okay, no, it's not quite true color. So different people's instruments, telescope, detector, filter combinations, have different color sensitivities. And so that needs to be corrected for so that you can compare your measurement to, say, somebody over in Japan who has a different system. Okay, so again, these 2 major color corrections need to be made. There are probably others too, but those are the 2 big ones. All right, now from Earth, we're all going to carry out measurements from Earth. So in the next slide, what you do, it's a lot like grading a quiz. Okay, you need to have an answer key over here, and you have the quiz here. The answer key cannot change throughout the grading. Okay, and so you compare your quiz to what it's supposed to be. And of course, the quiz is assigned a grade based on the answer key being 100%. Okay, so again, we're going to compare the brightness of our target to that of a comparison star. Now, the comparison star needs to be selected so that it has a known brightness. The brightness cannot change, or if it does, the change has to be less than the uncertainty of the measurement. If it changes by 0.1%, that's probably not going to be a big deal unless you're doing exoplanets. It also should be nearly the same color as a target. Now, that can be a problem for some of the planets. Some of the planets have a very non-stellar color. An example is Uranus and Neptune, particularly in red and infrared. Their near infrared and red color behavior is totally different from that of stars, and that's a problem. It's a big problem in those wavelengths. All right. All right, so now, I got into photometry largely because back in 1990, I was appointed the coordinator, or actually acting coordinator, of the remote planet section, and I realized, the biggest area I probably can concentrate on for Uranus and Neptune really is measuring their brightness. And I've been basically measuring the brightness of these planets ever since, and publishing the results. Of course, I do want to point out Jim Fox has done a wonderful job. He has been faithful in sending me lots of good measurements of Uranus and Neptune. I'm very grateful for him. Others have done a good job as too. But so anyway, on the next slide, I want to now talk about some applications. What is photometry good for? Now, of course, I didn't mention comets, and I really think comets is a gold mine of an opportunity, particularly for using different filters. I haven't really done that, but I do want to talk about some of the areas I have used photometry. For example, Mercury. Now, Mercury is an interesting planet because it's so close to the sun and its orbit. It is not circular, it's more like this shape, okay? And the sun being a lot closer at one end than the other. In fact, Mercury's distance from the sun changes by something close to 50%. Frank, you can correct me on that, but it's around a 50% change from aphelion to perihelion. And so what happens is Mercury grows hotter when it is closest to the sun. Now that shouldn't be a surprise. What's interesting and what's different between Mercury and the Earth, it's only about 2% closer to the sun in January than July. Mercury, like I said, is on the order of 50% closer to the sun when it's at perihelion compared to what is aphelion. Now, of course, as Mercury gets closer to the sun, it gets hotter. And of course, hot objects give off infrared light. And at least in the H filter, which has a wavelength of around 1.6 micrometers, I'm able to detect them. Okay, there's an actual thermal effect. So now there's the inverse square law breaks down for Mercury. Now, the thermal effects probably depends on the phase. In other words, Mercury can be anywhere from nearly full phase to a crescent phase. Now, how many people have seen the phases of Mercury? Raise your hand. From crescent to full. Good, good. I know, Frank, your hand better go up. Okay. Well, think about it. A crescent phase, the only thing you're looking at is that late afternoon portion that's bright or the early morning, either way. And Mercury really is not all that hot in the late afternoon or early morning. But if you see a nearly full phase, now you're looking at the hottest part of Mercury. So I would expect that you should get some thermal effects from that. Now I'm still looking at the data. I don't have enough measurements to detect that, but I feel I can. Now, something very recently, how many people have heard of the detection of a sodium flare on Mercury? Raise your hand. Really, really interesting. I believe it's Richard McKim of the British Astronomical Association, and of course the Mercury-Venus section of the BAA has put out an excellent newsletter, and in their most recent edition they talked about this sodium tail coming from Mercury. And what I would be interested in looking at is this related to thermal effects? Now, I'm not saying it is or not, but certainly I think it would be great. Thanks, Frank, for the comment. So again, this is exciting stuff. I think that it's just phenomenal that we have been able to image the sodium tail from Mercury. I really think, and of course, even Carl, you know, you're the comet person. This is sort of cometary behavior from Mercury. So again, I think this is really exciting. Right now, on the next slide, let's talk about Mars for a moment. First off, Mars brightens during an encircling storm. In fact, and by the way, when I say an encircling dust storm, I mean essentially one that goes all around Mars. I don't want to say covering the whole disk, but covering all longitudes, if you will. This was first detected actually way back in 1971 by some Soviet astronomers. It's part of the Soviet Union at that time, and it's now part of, I guess, Eastern Ukraine. And they noticed that Mars brightened in the V and the red filter by about 20 to 30%, but that it had dimmed in the ultraviolet light. This is really interesting discovery. Of course, I confirmed that in 2001 with that storm. Mars also changes color, particularly if you measure the ultraviolet and say the red. And the Soviets detected that way back in 1971. And to this day, I haven't seen anyone really look at that. I hope to do that once I get my strength back. Mars is also redder when it is at quadrature. Okay, quadrature is when it's about 3 to 4 months from opposition. And Mars is also a little bluer during oppositions that happen in January through April. So in other words, the oppositions in 2023, 2025, Mars is going to be a little bluer than say what it was in 2020. Okay, and again, that's partly due to Mars having more clouds. Right now, how many people observed Saturn? Julius, your hand better go up here. Okay, observe Saturn. Okay, what is the one thing about Saturn? Let's go to the next slide that you notice right away. Anyone? I can't hear you. What is the first thing you notice when you look at Saturn?
The rings.
Rings. Very good. Now, here are two images of Saturn, one taken about 13 years ago by Worsley, and the rings are nearly edge on. And then we have a picture by Trevor Barry taken just about 3 years ago. The rings are wide open. Now, obviously, Saturn is going to appear brighter when the rings are nearly open as much as they are. But of course, Saturn's color is also going to change. Okay, so let's go to the next slide. Let's take a look at this here. So the rings in different years, when open, Saturn is much brighter and is bluer. In fact, Saturn is over a factor of 2 brighter, I believe, in the V filter, the green filter. Okay, and this is pretty much confirmed in the near infrared. I've recently been doing the J and H filter of Saturn, and hopefully I'll be able to get back to that soon. However, there's something else, and I think Rick Hill has pointed this out. He sent images of it, known as the Seeliger effect. I hope I spelled that right. But basically, the rings are much brighter right at opposition, on opposition day, which I believe is going to be somewhere in August this year. Julius, you should probably, he'll tell us in his talk. And it can brighten by like 20%, the whole thing. And of course, more blue and less red during that time. So again, this is all things we've learned from photoelectric photometry. Okay, now let's go on to the next slide, which is Uranus. Now, Uranus. It takes 84 years for Uranus to make one trip around the sun. How long is one season? Anybody? About how long is just a single season on Uranus? Anyone? I can't.
24.
How long?
24.
Close, around 21 years. Yeah.
Yeah, 21.
21 years. So again, a season on the Earth, 3 months. Season on Mars, 5 to 6 months. A season on Uranus, 21 years. My recommendation is when someday there will be a new remote planets coordinator, try to pick someone who's young, because you're going to need, that person's going to need to live a long time just to see one season on Uranus. And of course, for Neptune, it's more like 41 years for a season. But anyway, Uranus undergoes a seasonal brightening. It is brightest when the polar region is facing us and dimmest when the equator is facing us. The equator of Uranus last faced us in 2007. The pole will be nearly facing us in about the year 2030, which is only 8 years from now. And here's what I have found out. And I think Karkoshka over at the University of Arizona has also found this. I mean, in fact, he's done more work than I have. Basically, the brightening is greatest in the near infrared and red, and it's kind of moderate in the visible, and it's kind of small in the blue light. And I'm not even sure about ultraviolet. Of course, I do also want to mention Wesley Lockwood has done a lot of work on this too. Very good comment, Rick. Yeah, it's like the 22-year cycle on the sun, magnetic cycle. That's very good. I didn't think of that. All right, so those are some applications. So just in conclusion, first off, photoelectric photometry and disc integrated, there's a lot of applications, but there's probably 10 times more applications. Hold up 10 fingers, everyone. 10 fingers, come on. There's 10 times more applications if you do disc resolved photometry. Now, this is possible with a digital camera, some calibration routines, and of course, you have to remember Mars is not a flat disk. It is spherical. So there's going to have to be some geometrical corrections, but I know a lot of you are very good at math. I'm kind of good at it, but I'm not the best at it. I've got to admit that. And the potential for the ALPO to do good disc resolved photometry is greater now than at any time we have existed. I think we can do more today than we could, say, 75 years ago. I know we've got a lot more competition today, but we have to think. Let's look at our resources. Just one example is the detection of a sodium tail from mercury. And I think that this is the kind of work that we need to think about and to read what other people are doing. I think I can't stress it enough, folks. Read what others are doing. There's great work being done. I know John Rogers is doing a great job with the Jupiter section. He's got helpers. And so hang in there. And I think the future looks bright for us. And that's all that I have to say. And I will answer any questions you have.
Yeah, Rick?
Yes,
Yeah, Rich, yeah,
right.
yeah, very good talk. I just want to mention, I just checked the chat system. In 2018, there was a dust storm at near our position. It was a dust storm, a planet circling dust storm. And I noticed that Mars was a little brighter, and someone said that it was about -3 instead of -2.8, something like that.
Yep.
And of course, I have very high reflectivity of the dust cloud because it's a lot of refreshing. Have you noticed that? Have you done a photometry?
Yes, I've done it, and like I said, Soviet astronomers have done it. And yes, it's about a 0.2 to 0.3 brightness increase when there's a planet encircling dust storm. I noticed it back in 2001. It's like a quarter of a magnitude or 25%. And similarly, the Soviet astronomers back in 1971 detected that with the Great Dust Storm that year. And then in 2018, I detected that brightness surge, but in near infrared wavelengths. And I actually talk about that in my photometry paper. I believe that was just published in the ALPO. But yes, that has been confirmed. Yes.
Okay.
Now, the one exception is ultraviolet light. According to what the Soviet astronomers reported, Mars gets dimmer in ultraviolet light. And I think that's a really important thing. That needs to, hopefully we can confirm that. Hopefully I can get my strength back to maybe carry out some ultraviolet measurements of Mars later this year with the hope that we're going to get another planet circling dust storm. Very good question, Frank.
So Richard, great talk. By ultraviolet, do you mean U band or B?
U.
U,
It's going to be around 370 nanometers, just a little too short for the eye to detect.
Yeah.
And it's the Johnson filter, I mean, too.
Okay, we have one question over on YouTube from Frank Dempsey. The question is for Richard. How common are photoelectric photometers, and how would one interested observer get one?
Okay, they're not that common. They were probably more common 20 years ago. CCD cameras have, if you can do CCD photometry, that's probably the way to go now. But I like the single channel. I'm I was kind of raised on that, and I would love to learn how to do CCD photometry, but I've been so busy with other things that I'm just sticking with my single channel photometer. Now, the way to get one is to look up the company Optec, OPTEC. They're based in Lowell, Michigan. Of course, think about Percival Lowell, and really great company. I've been doing business with them for 30 plus years, so I highly recommend them. They have great products. So Optec Incorporated, and you can even look at the manuals for the photometers online, and before you even purchase a photometer. So again, Lowell, Michigan, Optec Incorporated, OPTEC. Okay, thank you.
What would you suggest for standard stars? Would you just use a single standard, or nowadays, like we have the APAS survey, which is a double ABSO, covered all the stars, and I don't think all the Johnson bands. It was a mishmash of Johnson and Sloan colors, and so that way, with a CCD field of view, you might have different, number of stars in your field of view that have reasonable photometry within a few percent. But would you suggest kind of going that approach, or just picking one star that you trust that's at a similar air mass and just going back and forth?
It'd be good to do at least 2 stars. And they actually recommend 3 stars. That way, if you've got 1 star that's a variable, and more than likely, when I say variable, it depends what accuracy you're talking about. If you're talking about 2 to 3% accuracy, I would guess, and again, somebody may say, no, Richard, you're wrong. Maybe 5% of the stars vary by more than 2 to 3%.
Yeah.
But if you're talking about 0.1%, which is 1 millimeg, like for example, the exoplanets people, they want high degree of accuracy. I would say use a minimum of 3 stars for that. That way, because more than likely 1 or even 2 of those may be what we call micro variables. Now, they may not appear to vary at the 1 to 2% level, but at the 0.1 to 2% level, they will vary. In fact, our sun varies by about 0.2% or 0.002 magnitudes or 2 millimegs. So again, our sun is slightly variable even. But again, that's not a problem if you're doing, say, 2% photometry.
And how do you deal with doing photometry of such bright sources? Like, Mars could be -2, -3. Do you defocus it?
No. What I do is I will take, let's just pretend like I've got an opaque object here. I will drill a hole in that object. I've had to do this for Jupiter and Venus. Okay, and what I'll do is I'll take and measure Venus when it's kind of dim without the mask. Let's say I get a reading of 4,000. Okay, then I take and put the mask over it and measure Venus. Let's say it's 100. Okay, well, I know that the mask with the hole blocks out 40 times the light, going from 4,000 down to 100. So this is a factor of 40. That works out to about 4 magnitudes. So I have to factor that in. I've had to do that with Jupiter and for Venus and maybe Mars, but for sure Venus. Venus is so bright. And of course, I may have to do that if I do ultraviolet photometry for Mars, because again, Mars is very bright for the super sensitive instrument that I have in my mind right now. So
Thank you, Richard. Thank you, Richard.
Okay,
We're
you're
going to be
welcome.
moving along now.
Okay.
So I'd like to introduce our next speaker. And this guy, he's not nearly as visible as Tim Robertson. Tim has got so many things that he's going on, and we hear him on the podcast and so forth. But this guy is our assistant coordinator in the online section, Jim Tomney of, I don't know how it's pronounced. Is it Towson, Maryland or Towson, Maryland? Maryland's not a big place, so I assume it's there somewhere. And,
Well, we were famous on Seinfeld. That's where Elaine lived or came from. That's our claim to fame.
That's where Elaine is. Okay. Is it Towson?
Towson.
Towson. Jim is assistant coordinator, at least right now, but he will soon be otherwise. He's the acting assistant coordinator for the ALPO online section, and he helps maintain our website, as well as uploads images of the sun and the major planets to the ALPO section galleries. And as you heard Richard, he works very closely with getting images to Richard for his apparition reports on Jupiter and the remote planets. Last fall, Jim took on the job of chairperson for a committee that was tasked with reworking our website, which is very attractive, but perhaps it's outlived its appearance, its usefulness as appearance. And he's been actively working with others to redesign and code the website in these last few months with input from other committee members. And today, Jim is going to be providing us here with a sneak peek of what, let's call it ALPO 2.0, the website will look like. So, Jim, it's all yours.
All righty, thank you, Ken. As Ken mentioned, it was about this time last year that the board decided that they'd like to do a refresh of the website. And so we kicked that off in the fall of last year. The committee is basically Carl, Ron May, Tim, and Larry Owens and myself as the chair on this. And you know, we've probably met maybe 4 times since then, and have, as we have done certain sections, invited those section coordinators to review the work to make sure that it was looking good for them. And so what I want to do today is just to the general group here, kind of give you a little bit of a tour so that you can see what's coming. The main objective, you know, like Ken said, this site that we currently have is probably 15, maybe 20 years old. I don't think it's quite that old. But think about it. I mean, technology in 15 years has just changed tremendously. So it is time for us to kind of look at redesigning and updating the website to kind of keep pace with things. So 2 of the main objectives, I guess one of the first ones, is that we would like this ALPO 2.0 to better serve the needs of our members, you know, hopefully have more functionality for our members. And then the other thing is we want it to be a really nice, welcoming website for anyone that comes along, because basically your website is going to attract new members. You know, if your website is stale, people are going to go, well, I don't necessarily know that I want to join this group. So we really want to try to improve that. And, you know, we're just keeping up with the Joneses here. I noticed that the BAA, I think this past year, updated their website, and they have a dynamite website. It's very good. So what we're going to do today is kind of give you a little tour. I'd say maybe it's 25% complete at this point. It is in development. So, you know, we can click on a button and something might not go right. So, you know, hang on to your seats. Anything can happen here this afternoon. And I am going to post in the chat here. Oops, that's not the right one. Let me get this here. Okay, so what I have put in the chat is the URL to the development website. You can click on that and you're free while I'm talking to explore a little bit. Like I said, not all of these links are going to work. Not, you know, if you go to press the contact button, it's going to say something like placeholder for the contacts page. So, but feel free, you know, by all means, feel free to explore on it. So let me see if I can share my screen here. All right, are you guys seeing my screen? Good, thanks, Carl. All right, so this is the landing page of the new website. And you can see, let's see, first of all, it's broken up into, the design is like in sections here. So the front page is going to have 6 sections. Upper left is going to be announcements, like our ALPO conference or the Venus cloud discontinuity alert, things of that nature. In the center, we have little cards for jumping to the various sections. Right-hand side, top left, are going to be news headlines. And then the front page, these headlines will cut across, it's like an aggregator. It cuts across all of the various sections and displays them here on the front page. If you were to go to an individual's front page, like for example, Here we see the number 2 here is a news article about Clyde spot on Jupiter. If we were to go to the Jupiter section, let me, the thing with, well, we'll have to do that later. I was going to say the problem is, let me see, there we go. Here's the Jupiter section. So what you can see is that when you're looking at the Jupiter news, it's only Jupiter. If you are looking at the front page, it's cutting across everything. All right, so kind of below the fold, if you will, we then have events. So, and again, cutting across all the sections. We're also going to feature some of our gallery shots because I think that having a little bit of eye candy on the front page is not a bad idea. And then on the right-hand lower fold, a little bit about the ALPO because we want to try to encourage people to join. And then at the footer is, again, more information about the ALPO and how you can join. One of the key things that we're doing here is we are making this a responsive website. And what I mean by that is that you can view this website on a phone, on a tablet, or a desktop laptop. So if we shrink this up, you should be able to see that now, instead of 3 things across, we have them all down the line. And if you're exploring on a phone, this is probably the sort of view that you're getting. So, and that's very important because increasingly people are using mobile devices to access websites. So we want to keep our website responsive. So let's talk a little bit more about the news feature. Like I said, it cuts across all of the sections on the front. It's going to have basically a headline and then just a little bit of a teaser. When you click on the more information, it will tell you kind of the dateline, what section it's related to, where the article comes from, and again, a little bit of information about it. If you click the source article, it will take you to the original source article so you can read the entire article. So we're kind of looking to be a bit of like an aggregator. When you see an interesting article in a journal somewhere or Sky and Telescope or Astronomy, and you want to kind of draw attention to it, you think, hey, this is something that people who are interested in studying the solar system may enjoy, you can put a news headline in here. And that way, people coming to our site hopefully get the benefit of kind of like being like an aggregator where we have all the recent sort of news and interesting things that maybe you haven't seen before. Let's see here. Okay, the other thing is, oops, that was me. So you'll notice that in each of the headers here, if it is a hyperlink, it'll take us here, if I click on this to read all the news headlines. Here's another feature, is that let's say that there's a particular article that you maybe read and now it's like, darn, I can't find that thing. Well, here we've got them all listed in a table form. And the other really cool thing is here, you can do a search and filter down on this. So for example, we were just talking about that mercury sodium tail. Let's say, gee, I know I read something about it on the ALPO website. I'm going to type in sodium. And as I start to type in sodium, you can see I filter down to the relevant article, and I could then jump over to see it. One other thing I'll talk about while I'm here is that in general with navigation, anytime we have our logo, it's going to jump you back to the front page. And at the very top, we have our social links. So here is Twitter account, our YouTube channel that Tim works to keep up to date, Facebook, the podcast, and then we have a link specifically to join ALPO. And those will always be at the top on every page. So the events calendar is also very similar to the news. Again, cuts across all the sections on the front page. Each individual section has its own dedicated events. the objective of kind of like the news and the events components is to keep the content fresh. This is really what we're striving for, and to provide information that's hopefully going to engage solar system enthusiasts. How are we going to potentially do this? One of the things that we're hoping, I think, down the line is to maybe broaden the scope of people who could submit event items or who could submit news items. We don't want the webmaster or even the section coordinator necessarily to be a bottleneck. We really kind of want to, for lack of a better word, democratize people being able to contribute to the website and to provide information, whether it be uploading one of their most recent images, or whether it's, hey, there's an event on here that I think we ought to make everybody aware of. So let's talk about how we might be able to accomplish that. One thing I'm going to give an example of here is how to do the, if you had an event and you wanted to add it, let's see if I can bring this down. Good, perfect. Let's bring this over. All right, so I'm going to go to the admin section, and you'll notice it's going to carry me over to a page for me to log in. So we have authentication enabled. Members will be able to set up their own accounts so that they would be able to do things like this, and then they'll get to the administration page. So I want to add a calendar item. So I click on that, I give the date. So I know that next month on the 17th, we're going to have Perry Jove 44. So Perry Jove 44 observations needed. And this pertains to the Jupiter section. I'm going to save the changes. And then the next thing is that I have to approve it. So if we look on here, I hope. Here it is. Everybody see it down here. So again, somebody else, you've submitted it, somebody else is going to approve it. So I'm going to click edit. Here it is. I can make a change. Well, gee, Jim, we didn't need the exclamation point there, so I'm going to edit that. And then I'm going to approve it. So hopefully I go back to the front page and I look down in the events. And here we go. I didn't save my edit. I could go back and re-edit it if I want to. But that's just a quick look at how we are envisioning you guys submit stuff, give us content. We're going to do a quick approval of it to make sure that it's appropriate, and then it gets published live on the website. So that's kind of where we're going with this. Let's see here. All right, let's go take a look at a particular section. Let's look at the Jupiter section. This is kind of just as a example of how the various sections are going to look. So across the top, there will be menu items. These will be fairly standard. So a gallery, if we click on the gallery, you will get kind of similar to how the current gallery works. You can look at a particular apparition, and you can look at a particular photo. Let's see here. There we go. All right. And then I can return back to my Jupiter section. Publications. If the section has like newsletters, like I know that Jupiter did for a while, and I don't know whether we're going to be keeping this part or not. In talking to Craig McDougall, he did mention that really this could be supplanted with like the blog that is going to be a feature. But at any rate, if the section has newsletters, we're going to put them here. If there are particular books that we feel are of use or of interest, we may list them here in this section. Resources can take the form of forms. So here's a Jupiter observation form or an eclipse timing form. Our links, you can add links in here. And then we also have a frequently asked questions. How to join the email network for Jupiter. How to time and report Galilean satellite eclipse events, things of this nature. So that would be under the resources. And as I said, the contact isn't working at the moment. Again, here, the logo would take us back to the front page, but now the image of the planet takes us back to the home page of that section. All right, so now that we've done the menu at the top, let's look at what we've got here. We've got a blog where the section coordinator or assistant coordinator will be able to make a short, brief entry about something. We will have, again, the news headlines in the event calendar, which is like the front page, but it is filtered just on Jupiter. Below the fold here, instead of 3 across, we actually have 2 across. And we can have here a featured article. If your section has an article that they think is of interest and you get permission, you could have an article about, like, for example, using filters to view Jupiter. We also have the observation spotlight here, which I think is a great thing to highlight somebody's work. You know, you get maybe changes every 2 weeks. You know, you get in an observation and it's like, wow, that was really great. He had great seeing. You'd be able to display that on your website. Some other websites, some other sections, let me go back. You know, Jupiter is fairly popular, has a lot of material that we can use, a lot of content. The remote planets basically has only 3 across the top. You know, we've limited that to the headlines, the news, events, and the observation spotlight. Okay, and the bottom line is that this is all kind of like configurable stuff. That's another thing that we're really gunning for here. So let me go back to the Jupiter. I want to point out one thing to you. All right, notice that we have the observation spotlight, okay, a single image. Let's say that Jupiter's getting near solar conjunction and I want to do a retrospective, okay? So instead of the gallery spotlight, I'm going to do something a little bit different. And I need to get back to the admin section. Oh, wrong thing. All right, so now let's take a look at this. I can administer the section. And what I'm going to do is I'm going to pick Jupiter. I'm going to say go. Here I can edit the layout. So I currently have my display gallery. I'm going to uncheck that. And I'm going to do the gallery carousel. A carousel is nothing more than a series of things that go by like on a rotating basis, just like a carousel. I'm going to save those changes. And let's go back to the Jupiter section. All right, and as we scroll down, you will notice we now have a carousel here that will display apparition highlights. So you didn't have to bother the webmaster. You picked out a component. And again, this is kind of like the modular approach that we're trying to do. You know, maybe you want to have a poll for people in the Jupiter section of what filters do you use, or what camera are you using, or whatever. You could set up a poll, go in, administer it, and then publish your poll instead of having the feature article. So again, kind of like I'm trying to do highlights here, part of the design that we're gunning for here is some modular nature to this, to again, allow the ability to make it easier to keep our content new and fresh. So let's take a look now about what happens when we have sections that have like slightly different demands. So in the ALPO Comet section, one of the big things that Carl's group does is magnitude estimates. So you'll notice that across the top here, we have a new entry, which is database. So here is where we're going to have the information about magnitudes of comets. We've got a whole bunch of data here, and this is in the IQC format. It's a standard format for reporting comet magnitudes. So as a participant, perhaps, if I want to learn more about that particular format, I can go here. Or let's say I want to contribute my own observation, I can go here. And basically, we have a form that will walk you through, okay, filling out all the parts. And then when you eventually click submit, it'll end up providing that information in that format. But let's say I'm a pro and I just want to put my information in. So I'm going to go here to this part of the form. And what I want to do is enter in my observations. So I believe I have one up here, which I have stolen from the current website. So I'm going to copy this and I'm just going to paste it in here. So let's kind of, somebody keep me honest here. This was an observation for the 7th of July, 0.06. Okay, we're going to submit this observation. Okay, and as it says here, thanks for your observation. It's going to be forwarded and it'll be basically reviewed. Again, we don't want stuff just going in automatically. So at this point then, somebody like Carl would come along and here is a bunch of observations. You'll notice here is the one that I just put in. And I'm going to slide over a little bit here. And if it looks good to Carl or his designate, all he does is say approve. We go back to the comments section. Go back to the database. And yep, here is that one that we just added in. Okay, so again, the idea behind the website too is servicing our members to allow them to do their contributions a little bit more quickly and to hopefully see their contributions, because I think that's really important, whether you're taking an image of a planet or submitting a piece of data. I think everybody likes to see that their effort counts, and one way to do that is by making it visible on our website. So we're going to have other, what comes to mind clearly is the solar group, the lunar group, Mars. There are clearly sections that are going to need extra attention. And it's going to be a bit of a balancing act between getting full functionality with everything out there and launch date, because we don't, if we wait for a big bang, we wait and get everything together, it could be 3 years from now, which brings me to my point that if you would like to help, we are certainly more than happy to have people who are testers, basically going into the development website and poking at it. And you see something that looks wrong. I was poking at it the other night and I was like, oh, gee, look, all of the news summaries are the same for the planet Venus. So I had to change that. But testers, not a lot of particular specialized skill set is needed other than going to the website and kind of occasionally poking around at it and raising your hand and saying, hey guys, you got an issue over here on this page. Content providers, if you would like to begin to get trained up on doing content, we'd love to do that, and you can be submitting it. That would be awesome, because when you provide the content, that then provides material for the test, for the testers, and it relieves me the obligation of having to fabricate that sort of content for the testers to look at. And then finally, if you happen to have some .NET ASP code experience, especially like with Razor HTML or MVC, I know I'm probably speaking Greek to some of you at this point, but if any of you out there have those sort of skill sets, by all means, please get in touch with me, because we could certainly do the development a little bit faster if that's the case.
Hey, Jim,
so, yes, sir.
At this point, can you just give everybody the preferred email address for you? And then we'll, somebody went long.
I will put that in here right now.
Yeah.
It is alpo@tomney.com.
alpo@tomney, TOMNEY.com.
Right, it is in the chat.
Very good.
So, with that, does anybody have any particular questions or comments or anything?
Okay. We're going to go ahead now with the next speaker. I hope you had a great vacation, Jim.
Yes, thank you. My jumping off is not lack of interest. It's that I'm up here on vacation with my grandkids. So I will be catching all of this on YouTube. So everybody have a great conference. Enjoyed Richard's talk. And, let me hear from you if you guys have any sort of thoughts on the website. I would love to hear from you. Thanks very much.
Great job. Okay. At this time, I am tasked with yet another introduction. Everybody still out there? Okay, I'll assume the answer is yes. Our next speaker, before we have our mid-afternoon break, is Dr. Julius Benton. Julius is a longtime member of the ALPO. He is a retired aerospace executive who had been with General Dynamics. He retired in 2014 and had joined the ALPO back in 1967. Julius has been coordinator of the ALPO Saturn section and the ALPO Venus section continuously since 1971, only a few years after he joined. He's been an ALPO member of the board for at least 2 decades, and he has served several terms as the executive director of the ALPO. The executive director's term is a 2-year term that rotates alphabetically down the list of members of the board of directors. And the title of Julius's presentation will be Observing Saturn During the Current, that is the 2022-2023 apparition. And by the way, as I said, Julius lives in Savannah. So he's down on the Atlantic coast in Savannah, Georgia. Take it away, Julius. Are you there, Julius? Are you muted? We have Jim Melka's picture. Jim, are you muted? We need Julius Benton.
Okay, can you hear me?
Yeah, there you go.
Okay, great. All right, next slide. Okay, the guiding principle of the ALPO, we've discussed this many times before when we've had these conferences, is that it was established by Walter Haas back in 1947, is to encourage and coordinate regular systematic investigations of our solar system through instrumentation that's available to amateur astronomers. And that equipment is really becoming more and more sophisticated as the years pass. Next slide. Okay, the value of Saturn observations. Amateurs have the freedom to observe at leisure for extended periods of time. Systematic observations provide a long-term record of study by professional astronomers, and we keep a nice long database that's quite detailed and is archived for research purposes. Professionals have desired high-resolution images by amateurs, such as the Cassini mission, which ended back in 2017. And then skilled observers routinely produce excellent digital images at various wavelengths in the ongoing pro-am endeavors that we continue to participate in. Visual observational work, of course, by amateurs is still not obsolete, and we continue to encourage observers to make drawings of Saturn, as well as doing the digital imaging, which is very important to our total database. Next. Minimum equipment. I'm always asked, what size telescope should I use for observing Saturn? We don't set some inflexible minimum, but observers can start out with a small refractor, a 10.2 centimeter or 4-inch refractor, or a 6-inch Newtonian or catadioptric. A good equatorial mount really helps with the clock drive. Color filters of known wavelength, and using a reliable ephemeris such as the Astronomical Almanac, WinJupos, or WIMP, which gives us a lot of information on where Saturn is located, as well as data on the planet itself in terms of magnitude, the CM transit, the CM longitude and latitudes, That's a big help to us all. Software, if you have a laptop, you can do digital imaging successfully, and you've got to have suitable software allowing image capture and subsequent processing. Some keys to meaningful results. Saturn apparitions last about 378 days between conjunctions. Plan your observational programs well in advance. Start observing early in an apparition of Saturn and maintain consistency. Keep an accurate observational record of what you are seeing, the UT date and time, location, telescope magnifications, and filters employed, and use the standard ALPO observing forms available on our website for download, and submit observations regularly via email or regular mail. We strive for simultaneous observations as much as possible to get confirmation of variable phenomena on the same date and the same time. Make sure we get confirmation is a big thing to document things objectively. Okay. The observing program, visual numerical relative intensity estimates. Richard alluded to photometry. This is a visual photometry process that we've been keeping records for years. And we encourage observers to use a numerical relative intensity estimate process. And that's outlined in our Saturn handbook. Full disk drawings of Saturn are still valuable. We have forms that are allowed to allow that to happen with the proper geometry and the ring tilt, so it makes it easier to draw Saturn. Digital imaging of Saturn at multiple wavelengths is ongoing rapidly now. We have over 700 images this current apparition. CM transit timings of notable atmospheric phenomena are important. Visual estimates of belt and zone latitudes, visual detection of intensity minima in the ring, and also the bicolored aspects of the ring ANSI and brightness asymmetries around the circumference of ring A. Accurate timing of stellar occultations by Saturn, and recording of transits of satellites and their shadows across the globe at or near edgewise ring inclinations. Visual magnitude estimates are still of Saturn satellites are still valuable as well. Okay. This is an example of our drawing form that I mentioned before that shows a blank of Saturn for the current apparition. It really facilitates accurate drawing of Saturn. So it's pretty difficult to draw Saturn freehand without some sort of template to use for your observations. This form allows you to enter the information that I mentioned earlier, the name of the observer, the location, the time, instrument used, filters that are employed, and there's a space below for intensity estimates. And these are available on the website, by the way. Okay. This is a representative standard nomenclature for Saturn. Gives the basic information that observers need to know. If there are questions about what you're looking at on Saturn. This emphasizes the northern hemisphere of Saturn at the present time. And during this apparition, more and more of the southern hemisphere of Saturn is coming into view now for observers. And you start seeing that in some of the images that we've got presented here in this presentation. This is the normal inverted view, by the way. The changing aspect of Saturn's rings. Back in 2017, Saturn was at its complete maximum inclination towards our line of sight at approximately 27 degrees. And the last edgewise presentation of the ring was back in 2008 and 2009. And the next won't occur until 2024, 2025 apparition. So Saturn's rings are starting to close up now as the apparitions progress from year to year. Next. Okay, Saturn will reach opposition to the sun on August 14th, next month. So here's some basic opposition data that is helpful. That's been published in our journal. Observers can look that up in the latest journal, and it gives that information in the updates I give on Saturn. Saturn's globe is about 18.8 seconds of arc equatorial diameter, and the ring tilt now is about 13.7 degrees to our line of sight. Saturn is kind of low in the sky for some observers. The big advantage for our southern hemisphere observers at minus 15 degrees, 0.4. Next. Okay, here are some representative examples of some of the current images of Saturn taken at different wavelengths. You see there's a lot of phenomena that's being captured on these digital images of Saturn. Most of the observations that we have right now are coming in the form of digital imaging. Some of them very impressive. And we're trying to document recurring phenomena in the various belts and zones on Saturn. And the previous nomenclature diagram can help observers get a fix on what they're really looking at and when they're comparing images with one another. I've just labeled here some of the key things that have been seen on Saturn. There's some bright spots that have been located in the northern hemisphere, in the various belts and zones, a curious white streak in the equatorial band, and some small white spots that are appearing in the equatorial zone, as well as in the northern north polar area. Go ahead. Here are a few more examples. You can see in one of these images here at 685 nanometers IR. I've labeled some things on the image showing some of the phenomena that's being cited and re-imaged over and over in the southern hemisphere that's becoming more visible as the rings continue to close up. So we're seeing more and more of the southern hemisphere as Saturn progresses more and more towards its edgewise presentation in a couple of years from now. Next. Some highlights of the 2023 apparition. Observers are starting to notice quite a number of features that are in the belts and zones. There's a recurring white streak that's been imaged in the equatorial band at 5 degrees north Saturnographic latitude. Some white streaks in the NEBS and NEBM detected at plus 14.5 and 16.0 Saturnographic latitude. And then there are many other features that are being imaged and followed along with the apparition as it goes forward. These are recurring, and we're trying to keep track of these and make sure we have a lot of documentation of what the atmospheric phenomenon is and what does persist over the months ahead. With opposition coming up on the 14th, we'll be seeing Saturn well placed for observing most of the night. And we encourage observers to participate in our program and observe Saturn and image it as frequently as possible. Okay. Resources for Saturn. My book on Saturn and how to observe it is still available on Amazon. And this other monograph about visual theory and methods for visual observations of Saturn is on our website for free download for observers. It's a PDF format. And so that's basically the content of my discussion. I welcome observers who join our programs and to participate on a regular basis. If there are questions about how we run our programs, feel free to contact me and I will help you out as you progress through our programs as a beginner as well as an experienced observer.
I'd like to really repeat to all of us that Julius pointed out that Saturn is now, what is the rising time these days for Saturn, Julius?
Oh gosh, I get up in the morning, really early in the morning. It's up about 3:30 a.m. in the morning. And of course, that's Eastern time.
Yeah.
But I'm getting a lot of observations for those guys down in South America, South Africa, also observers in Australia. I have 700 images already for this apparition. I get 30 and 40 images a week. It's really growing in numbers.
You've got a dedicated crew. Anybody else with questions on equipment or anything to use? There's Richard Schmoody. Richard, are you muted?
Okay, Julius.
Yes.
Have you published, has Springer published the second edition of your book? I know you've done this first edition, I've got that, but is there a second edition?
Yes, that manuscript has already been submitted, and it may not be Springer that will actually publish. There may be a different publisher. There's a possibility that Cambridge might pick it up.
Oh, that would be nice. Whoa, okay. All right.
Cambridge is very difficult to work with sometime for previously published books by another publishing company.
Yeah.
They've been very cooperative, and we are looking forward to seeing the next edition. It's probably 2024, but that'll ever, you'll see it in the lighted page. Won't be out until then, probably. There's a lot of stuff to update in that book that I want to add information on imaging and that sort of thing, which was the original book was not as strong on.
Thank you, Julius.
And another thing, Richard, I mentioned the visual photometry.
Yeah.
You were interested in that when we had our previous discussion last year.
Yes.
And it is continuing right now. I'm encouraging observers to do that because we have shown some variability over the years. And you'll probably see a paper that I published back some time ago showing variations in the brightness of Saturn over time.
I think I've seen that paper, but yeah, once I get an interest in that again, I'm going to want to look at your data as well as the BA8. Richard McKim published some very good work too. I know that.
Yes, we have to convert some of the intensity estimate templates for that to occur between the BAA and the ALPO because there's a conversion factor that Walter produced some time ago to do that. It really works out well.
Oh, thank you very much, Julius.
I'll make that available to you if you want to get that. If you don't have a copy of that paper, I can send it to you.
Okay.
By the
Okay.
way, Dan Ward just interjected that the rise time for Saturn is 9:40 p.m. Eastern time, which is very encouraging.
Well, the interesting thing is that I have got trees around my house, so I have to go out when I can do it. A lot of people face that challenge, and of course, I don't mind getting up and observing Saturn and catching it at the right time. Now, when it gets time for opposition, it'll be a little bit easier for most of the night.
Yeah, you could fix that. You could fix that with the chainsaw.
Yeah, or axes. That's why they were invented.
Yeah, exactly. I've had some trees cut down for that purpose, but that's not the only reason. I got trees cut down around my house because of hurricanes.
Yeah, I just bought a chainsaw and a pole for that very reason.
There you go.
As soon as the temperature gets below 105, I'll make use of it.
Yeah.
Oh, yeah.
All right. Well, Julius, thanks a lot for that and getting us back on schedule. I appreciate it. When you do your Jupiter talk tomorrow, maybe you can, maybe you can talk, maybe you can breathe actually during it. So that'd be nice. But thanks for getting us back on schedule. Okay,
yep,
we're gonna
Venus tomorrow.
Venus, that's right, Venus. I'm sorry. So we're gonna take a break right now until about 20 minutes after the hour. So go ahead, grab a bite to eat, do whatever you need to do, and we'll see you all back in 20 minutes.
Hey, Tim, I'm up next, right?
Yes, you are. You're right there on the schedule.
All right. Just wanted to make sure, do a quick sound check, make sure you can hear me okay.
Yeah, you sound great.
All right. Awesome. Thank you so much. I'll see you in 20.
All right.
Harrison, whereabouts are you located?
I'm in central Louisiana, Alexandria. So right in the middle of lots of humidity and hurricanes and, well, the desire for some chainsaws too.
Andrew.
but I just thought I might share. At least the things which cause me grief. Can you feel my spirit in the room whenever I'm not there? You're alone, your heart cries out. Yes, I am aware we all make mistakes. And we love the love, you don't feel the same. Lettuce and tomato. That thing. Your face looks like a face from the fish.
Whoa.
All right, it's about time. Everybody hear me? Yeah, okay. Looks like right now on the Zoom, we have 33 people, and over on YouTube, we have 29 people watching, and there's people from all over the world. So this is kind of great. I kind of like it. Okay, Ken, are you on? You can. Ken, come in. There you are.
There you are. Ready? Harrison Doan of Alexandria, Louisiana, is an engineer whose interest in planetary geology, excuse me, and the human perception of time led to the field of astrometrics. His presentation this afternoon is about using the position of celestial bodies to determine the date and time. Interesting. Take it away, Harrison.
Thank you so much. Let's see. All right. Are you able to see my screen there?
Yeah.
Great. So I could have called this presentation Astrometric Chronodetermination, but that really wouldn't be a known term. I don't think anybody would recognize that. So we're going to spend the next few minutes discussing the ideal method for finding the date and time using solar system objects. Now, why would this be of interest? In our date and time, we've got a lot of modern technology. We can get accurate time just about anywhere. Well, there's some circumstances under which our time gets lost. And there's two primary methods for losing time. One, technology quits working. And we hear about this with things like, coronal mass ejections, major meteorite strikes, and there's any number of man-made catastrophes that could really wreak havoc on our timekeeping technologies and systems and distribution networks. And then there's, our lack of access for some reason. If individually somebody is isolated here on the planet, or if they're out traveling somewhere somehow, that is something that is becoming a more and more common possibility. And then there's also the problem of the human perception of time changing. And, this would be due to the Earth's motion changing, either its rotation or its orbit. And its rotation actually, scientists will tell you today that its rotation actually changes presently in very small increments, but that can become very large increments. This can be due to an increase in kinetic energy, major meteorite strike. Elon Musk decides to fire up all his rockets pointed the same direction for some reason. Or also shifts in mass. For example, the melting of the ice caps, tectonic plates shifting, landslides, mining operations, damming operations like the Three Gorges Dam over in China. Things like that shift the Earth's mass, and that impacts its rate of rotation. But if the sun's mass changes, that's going to impact the planet's orbits. So how do we go about finding the date and time? Well, there's just three simple basic resources that are needed. One, a visual aid, a telescope. Second, a means of measuring the passage of time. This doesn't have to be terribly complicated. This can be a simple chronometer, a quartz clock, a pendulum clock for that matter, as long as it's a good quality timepiece. And then it's necessary to have the astrometric data, preferably all in one spot, nice and concentrated. And of course, under these circumstances, you're going to want something that's printed, not something that you would be trying to get off the internet or something like that. That would not be a very, very prudent course of action. And then there's a process. And the process involves creating really a funnel that narrows down the uncertainty of observations. So you'd have to start with an initial broad observation. That would be using galactic motion to determine, the year plus or minus a couple of years. You're going to be able to get that within a decade with relative ease. Then you're going to use the location of the planets in the night sky. That's going to narrow that down to the year, the day, and then the moons, especially of Jupiter, that's going to help you to narrow it down to the correct hour, minute, and then finally the second. And with galactic motion, you're going to want to use relatively fast-moving stars. 61 Cygni meets all those general qualifications here in the Northern Hemisphere. It's easy to identify. It's fast-moving east-west and has all the right characteristics. You're going to use what's called a star transit method to compare the position of relatively static background stars to determine the position of 61 Cygni. And then that will give you, relatively the year. And for those who aren't familiar with the star transit method, that means allowing objects to pass a fixed point, like a reticle in your eyepiece, so that you can time and estimate the position of celestial objects. And then moving on, you're going to use Saturn. And Saturn has a 29-year orbit. So you're going to be able to narrow down that uncertainty by looking at the position of Saturn. And for this purpose, you don't need to really do a star transit method and get the precise position of Saturn. It's just not necessary. You're only really trying to, get that funnel just a little bit narrower, so that you're going from plus or minus years to plus or minus maybe about 1 year, maybe a little bit less. We can ignore parallax, retrograde for now. But by the time you get to Jupiter, making an observation of Jupiter, again, you're going to want to use that star transit method. You'll be able to precisely determine the position of Jupiter in the night sky. And you're going to be able to determine exactly where it is in its path along the ecliptic. And that's great, but you're going to be dealing with a geocentric position from here on Earth. And so we all know that means that you're going to be dealing with issues like parallax. You're going to be looking at the sky and be like, okay, there's some retrograde that's going to make for some really messy charts and calculations. So what's necessary, what can be done, is you need to determine Jupiter's position from a heliocentric point of view. And that means that you have to determine Earth's position. Okay. And by observing Earth's position, you're able to do a little bit of fairly simple trigonometry. Remove the parallax. Actually, in this case, it's geometry, not trigonometry. You're able to remove that parallax and be able to determine Jupiter's heliocentric position in the ecliptic. And that is able to reduce the uncertainty of Jupiter's position to plus or minus about a day. I've actually achieved less than that, but realistically speaking, considering all the margins of error involved, you're going to be looking at plus or minus about a day. So that gets you the date. How do you narrow down that uncertainty even further? Well, you need to observe the position of Jupiter's moons. And what you're going to be looking for specifically is Callisto at its maximum elongation. That's the point that it is furthest from Jupiter's body. And that's going to give you a sense of scale for exactly how big everything is that you're looking at there. You're going to be dealing with some funny angles and things like that. But in doing that, you're able to determine Ganymede's maximum elongation. You can calculate that, do a little bit more math, do some trigonometry, and this time you'll be able to figure out the exact longitude of Ganymede at partial elongation, and then determine when Ganymede, you can estimate when Ganymede is going to enter and exit in eclipse. All right, and this reduces your uncertainty to within a few hours, and that's mostly because of the lack of precision in using such rudimentary star transit methods for making these observations. But to reduce that uncertainty, again, even further, okay, you're going to be dealing with an uncertainty of hours. You can do the exact same thing, but in reverse, and observe a transit or occultation. And in so doing, okay, the beauty of this is it's not a binary event, something that you either see or you don't see. You can see a transit approaching Jupiter's disk. You can see when it actually touches the disk. If you've got enough magnification, you can watch it merge into Jupiter's disk, and you can tell that moment when the two actually start to touch. That's when the transit actually begins. And so this is very useful for being able to reduce that uncertainty, especially if you aren't sure of exactly when this event is going to take place. Again, do a bit of math and you're able to reduce your uncertainty of the date and time to plus or minus about 15 minutes, maybe a little bit less depending on some circumstances. And then things get real interesting. This is the moment of truth. Being able to observe an eclipse and match this with ephemeris data. Okay. And depending on the quality of the observation, the equipment being used, the sensor, are you using the human eye? Are you using a camera? Atmospheric conditions. I've done this a number of times, and let me tell you, there's so many variables that kind of get involved in that. So it really does have an impact on the accuracy of the observation. But this is the exact same method that was being promoted hundreds of years ago by the likes of Galileo, Newton, and others for solving the world's biggest problem at the time, which was determining longitude. And this really is, as best as I can tell, the ideal method for determining the date and time using solar system objects. This really reduces the uncertainty of the date and time to within seconds. I think my best calculation has been to within about 5 seconds. And what do you do with it? What do you do with this information? Well, you can start by setting a clock. You can check its rate if you make more than one observation and having a clock that has a known rate, knowing the time, this is a useful tool. Because remember, this works even if the position of the Earth, its spin, is not known. So you can now use this as a tool to check, determine, there's some major catastrophe. Is the Earth still spinning at the same rate? You can do a lot of that observation that would otherwise be highly dependent on technology that might not be available for whatever reason. And there's other things that can be done. You can use this information for, that next solar eclipse. You can watch for that transit of Mercury that you're looking for. And if a space traveler for some reason overshoots expected velocities on his way to Mars or something like that by a very large margin, we just don't know what could happen there. But you'll be dealing with issues like time dilation, and that would certainly maybe confuse some things for that time traveler. And they're going to need a way to do some astrometrics and time calculations, and they're going to be following these same basic principles. And there you go. So, any questions?
This is
Yeah.
Richard.
Go ahead. All right.
Okay. Harrison, very good talk. Now, how about Venus? I believe that either the Mayans or the Aztecs use Venus and base their calendar on it. And Venus repeats, as you know, about every 8 years. How about that?
It's true, but because it's on basically the inside of the solar system, observing opportunities and the precision that it offers really just doesn't help that much.
Okay.
For example, like with Mars, man, it's very fast moving, but there's very large chunks of time where we just can't observe it.
That's true. Yeah.
Jupiter and Saturn, the time that they're unavailable to be seen is actually quite low, relatively speaking.
Mm-hmm. Okay. Very good point.
Yeah, Harry, I just want to point out, I just text you, everybody, about the space mission. This is one example that timing is very important because, for example, like the Galilean satellite with the mutual and occultation events, timing is very important. It has to be they were trying to get very accurate timing when occultation starts or when an eclipse starts. This is very important for the space mission because if it's not accurate and the space station, the space mission, they have the time set up to go to the proper destination. If it's off by a minute or two, it's going to be much further away or maybe too close, and it could be dangerous for the space mission. And if it's not very precise with timing.
Absolutely. You're right, Frank. Absolutely. Same basic principles. I have a lot of people kind of ask me, let's see, what was how's the Earth's longitude found? That's a very interesting little technique that involves using a solar projector and observing the sun at noon, and then using a reticle eyepiece along the ecliptic at midnight. And that method, in spite of its many imperfections, actually turns out with some very, very accurate results. And another question I get every now and then is, why do I bother with Ganymede? And it's because Callista goes through a 3-year period where it just doesn't cross through any of Jupiter's shadows. It doesn't transit. And so it's not a very suitable target. And the other one that I get every now and then is data. Where do I get my data from? There's a lot of different data points with a lot of, very professional organizations, some of them more so than others. It's not that common actually these days. It used to be more common. But all this data, I compiled it together in my first book, A Measure of Time. And that's it's a little thing, handheld size, pocket. And I did that more than anything for my personal use. And eventually, here shortly, I'll be doing the full unabridged When Time Ends. And that's a much heftier publication. That's going to be 300 some pages, full ephemeris, and all sorts of details on how to actually do this with the utmost precision, all the explanations needed in there.
Have you got a publisher for the When Time Ends book?
I don't. Right now, I've been just contemplating self-publishing on Amazon, but I'm certainly open. Love to have somebody have a look at it before I present it to a publisher. But I'm open to possibilities.
Well, various members have used Springer for what it's worth.
Yeah.
And I'll contact you offline.
Sure, sure. Yeah.
We've got a few minutes yet. If there's anything else you'd like to do, more about your books or more about yourself or something, we've got a couple minutes.
Well, you guys said to keep it down to 12, 13 minutes. I took it seriously.
I'm sure someone else will eat up some time a little later. So good job, Harrison.
Thank you so much.
At this time, we're going overseas. Everybody hold on tight. Our next speaker, oh, I practiced this last night. I'm going to goof it up now. Dr. Anthony Cook, Tony Cook, is a lecturer in the Department of Physics at the University of, oh God, Aberystwyth.
Aberystwyth.
Hey, what he said, in the United Kingdom, but had previously worked on research projects at the Institute of Planetary Exploration, Berlin, and the Center for Earth and Planetary Studies at the Smithsonian's National Air and Space Museum in Washington, D.C. He is currently the acting director of the BAA's lunar section and runs the ALPO and the BAA's lunar transient phenomena programs, although the BAA has a new name for it. I'd like to have him explain that. It's probably a more accurate title. The ALPO and the BAA lunar sections have started a new project to measure, describe, and catalog lunar impact basins, and also to discover previously unknown lunar impact basins and buried craters. Whether an impact basin is a real impact basin is not always so clear-cut, and even in the professional literature, there is some disagreement over what are and what are not basins. At the very least, we shall collect evidence for each candidate that could be used to support or contradict impact basin proposals, and also establish over what range of selenographic co-longitudes the basin structure is best seen at on the morning and evening terminators. You got that? So Dr. Cook, let's see, it's about 3:45 or so here in the Eastern time zone in the United States. What time is it for you? And take it away.
Yeah, over here in Wales, mid Wales in the United Kingdom, it's 20:43 in the evening. It's still daylight, which is nice. And it hasn't been too hot, which is good. We had a couple of very hot days on Monday and Tuesday, even hotter than Spain, and caused a lot of chaos here because we're not used to those temperatures. But anyway, let's begin. Okay, right. So, I'll just move some of these things out the way a little bit if I can. This always seems to happen on Zoom. Well, we'll just carry on like this for the moment. So, in this lecture, I'm going to talk about what is an impact basin, There's some clear distinctions between those and craters. Talk a bit about morphology, which is a very sort of geological word. It just basically means sort of description of landforms and how you describe things. That's what it's all about. Talk a little bit about gravity data, but not too much because it's very technical. Then mention some previous work on catalogs and where we can find information about impact basins, sizes and names. And we're not completely just interested in impact basins. We're also after, whilst we're doing this, we can use similar techniques, which I'll describe, to look for buried craters underneath the moon, or sometimes referred to as ghost craters, which don't make it into IAU catalogs and things. I'm going to talk a bit about the ALPO, BA and SLA program, and any other society which would like to join in. Don't think it's just these three societies. Any other society can contact me and I'll give you instructions on what to do, and you can get your members locally to try to work out what are impact basins or not on the moon, or buried craters. So let's begin. So basically, an impact basin is a big crater, and I was told when I was on a module at University College London that they're basically craters which are bigger than 300 kilometers across, and that's called an impact basin. I've learned since then it's not quite as clear cut as that, but it's a rough estimate. Impact basins about 300 kilometers across. Also, unlike craters, apart from some of the really big craters, impact basins have got multiple rings. Sometimes they can have, instead of the crater having one ring going around the edge, basins can have 2, 3, 4, 5 or more. Valhalla on one of Jupiter's moons has got, I wouldn't like to count how many it's got, but it's got sort of probably tens or maybe 100 rings going around it. Basins have names like the Imbrium Basin, the Mare Imbrium, but some of the less well-known ones, because they don't make it onto the IAU list of names, they don't have any Mare in them, people tend to give them two names. That's a couple of craters which span the basins. You've got Bailey, Newton, and other basins like that, until eventually people give them names. Now, the largest official impact basin on the moon, which we know about, is the South Pole Aitken Basin, or SPA for short, and that's a massive 2,500 kilometers across. Some of the other basins you will barely see, and that's what we're interested in, trying to detect these, because these are really ancient. They tell us about the early history of the moon. Why do basins matter if the IAU don't always give them names? They matter because they're caused by large asteroid-sized objects, maybe 100 kilometers across in some cases, which smash into them, maybe bigger than that, which are getting to the scale where they could actually smash the moon apart. Now, we know this happened with the Earth, when the Mars-sized object hit the Earth. Similar things could happen with the moon and other objects. So they're pretty important thing, impact basins. They're the precursors to an object breaking up from a larger object hitting it. They're getting on in that direction. The other important thing about basins is they give geological eras to the moon. Most of the geological eras on the moon are named after basins. So you've got pre-Nectaran, which are anything before the Nectaris impact basin. You've got upper and lower Imbrium, which are to do with different, around the time of the Imbrium impact basin, and Nectarian as well. And then we go on to craters like Copernican era, that kind of thing. But you see, they're very important for the geological era on the moon. They're like they tell you how old things are. I looked at my lecture notes from when I was a student, and we had Professor John Guest teach us at University College London, and this is just a hand-drawn cross-section I did through an impact basin, which he drew on the board, and it shows the multi-ring structure there. You notice it's steeper on the inside, facing inside, and slope away on the outside, and this is a 3-ring basin there. It's got a lot of cracks going down into the ground. Some basins have an inner ring to them, so you get a peak ring in the middle. And we have that also with some of the larger craters. Because the moon's crust is thinner on the near side, these basins go pretty deep when they form, and lava bubbles up from underneath and floods the floor. Not immediately, it can take happen many millions of years afterwards, but a lot of the basins on the near side have black basalt mare areas on the bottom, and a few on the far side as well, but it's a thicker crust there. Another thing basins have, they have mass concentrations near the center usually, and I'll talk about those later. They're called mascons. The other thing you'll notice in this hand-drawn diagram, but you can see it on images, there's a lot of grooves running radially away from basins, basically from things the size of Everest or other mountains being thrown out and bouncing across the horizon, scouring out the surrounding terrain. Pretty energetic things are basins. And the other curious thing about some basins, not all, is if you go exactly 180 degrees around the moon, almost exactly 180 degrees, you'll find the land there looks a bit different. It's sort of chaotic. I'll show you a picture of that later. And also, the surface is sometimes magnetized. The moon doesn't have its own magnetic field presently, but the surface has been magnetized at these antipodal points. Now, the basin rings, there's a mathematical formula, and they fit quite nicely to that. The radius, or rather the diameter, changes each time by √2. That's 1.4 something, isn't it? So the first basin there has got a radius of that, and then this one is the ring there has got a 1.4 something times that, and then 1.4 something times that, and so on. So this mathematical expression, and that can be useful for confirming if we have a multi-ring impact basin, even if it's highly degraded. If you fit these circles through the remains of the rings, that's a good indicator that you've got an impact basin there. Here's one on the far side, the Mare Orientale, just over the moon. You can see that occasionally, little bits of that when the moon librates, wobbles on its axis. You can see some of the bits coming over. That's 327 kilometers across, and that's one of the youngest basins on the moon. Mercury, I just thought I'd talk about that a bit. That's also follows a similar rule with the ring ratios, but the gravity is different. So it's twice the gravity of the moon. So the rings are a little bit not so high on the planet Mercury, presumably due to gravity pulling things downhill. So moving on to these mascons, or mass anomalies. In the 1960s and 1970s, NASA was flying lunar orbiter missions around the moon, and I think Explorer 35 was thrown out of an Apollo spacecraft in orbit around the moon into a low moon orbit. And they noticed these orbiters didn't go according to plan. They would sometimes, over the Mare areas, as they were approaching, speed up and get closer to the moon. As they went away from the center, they'd slow down and move out again. And these caused some orbital instabilities. I think the Explorer 35 mission crashed into the moon after just a month or something like that. I probably got that wrong, but it was a lot shorter time than they were expecting, caused by these gravitational anomalies. And what's happening there is you've got this is a Mare Smith. You can see the mascons over there highlighted in red, right at the centers of a lot of basins. What's happening is the basin is a depression, and this is a plot of the topography, and this is the gravity underneath. And basically it sort of mirrors the topography. You get an area of mass underneath, although the crustal thickness is thinner at the center. There's a lot of denser material which surges in underneath and then freezes there, cools down. You've got this higher density area underneath, surprisingly, even though the crust is thinner, pulling satellites down a bit. Right, when you look at these basins with gravity data, we have excellent gravity data from the Grail mission now. You can see these bullseyes effects where you get these gravitational anomalies. There's a mascon in the center. There's also this bullseye effect around there. So that's usually a good indicator that we have an impact basin. If the gravity looks like a bullseye, it's probably an impact basin. But not all impact basins have these bullseye effects and mascons. So here's Mare Crisium. That's a nice elliptical basin because the object came in sideways. This is Mare, the Tranquillitatis Basin over here, and we don't have anything looking like that. So it may be these basins, and the South Hoakian Basin, the biggest basin on the moon, doesn't have a central mascon. It may be that that central section of crust where the denser material was, it was such a large basin, and the crust was perhaps a lot thinner, and the interior was hotter, that due to viscous relaxation, it's a bit like treacle, caused that more denser area to fall down towards the center of the moon, and you lost your mascon. That's just a theory. I think you need to talk to geologists and read up papers to see what the current theory is on that. But it's, yeah, mascons are a good indicator that it's definitely a basin, but it doesn't have to have a mascon. And that usually is an indicator it's a pretty old basin. So do basins have to show nice bowl-like depressions? Again, the answer is no, because if they are really ancient, pre-Nectaran in age, which are the oldest basins, then although yes, they do initially have that, over time, things can happen. For example, lava can flood a basin. You still might have a bit of a basin there. You could have ejecta thrown out from other basins landing on top and covering things up. You can have other basins intersecting your basin and destroying the interior somewhat. So lots of things can happen, and all you will be left with, as you can see in this discovery image of the Bailey-Newton basin, you just get remnants of the rings around there. I was told once by planetary scientist Mark Robinson that you get topographic highs occurring where rings from two basins intersect. So here's a South Poakian basin, and here's a basin that intersects. And even though this basin might get destroyed by the South Poakian if it was previous to that, some of the topographic highs you can still see with the peaks here, where you get the intersection of the rings. Similar thing applies to craters which intersect basin rings as well. The rims of craters can be a little bit higher, get less eroded where they intersect a basin rim. Right, where do we find lists of basins? There is no official International Astronomical Union list of impact basins. They want to name craters, that's fine. Some of the Mare areas are in basins, so they get names, but they don't have things for the South Pole Aitken Basin as far as I can tell. So if you want to look for things, look for recent publications like this one by Neumann. That's a pretty good one over there. If you click on these, you can go to those. The Moon Wiki, that is an excellent resource for many things to do with the moon. I would highly recommend looking at that if you've never looked at that before, and that lists basins as well. Even suspected basins and basins which have fallen out of favor, they are listed in there and mentioned as such. To learn a bit about the dating of basins, have a look at this paper by Harry Hiesinger, Journal of Geophysical Research. I'm ashamed to say I've also found a few basins. There's a LPSC, Lunar Planetary Science Conference abstract there, which lists a few basins we found using Clementine data, where I produced a digital elevation model of the moon, covering the whole moon back in 2000 before Lunar Reconnaissance Orbiter data. And then the Chinese have been busy also finding basins, and you see an example over there, but I can't find a list of their basins, just a nice pretty picture. So what we're going to try and do, and we're hosting this at Aberystwyth University in the physics department, is to put a couple of spreadsheets on there listing all the basins we can find in the literature, all the buried craters, and over time we'll gradually add to that information about ring size. You know, a lot of basins have ring size, so we can update those a bit, and also the best longitudes to see them at sunrise and sunset, so you can take lots of nice pictures of them in future. We're encouraging you to go out and take pictures for us so we can work out the longitude and enter that into the database. It's never been done before, so it's worth doing. Okay, buried craters. So what we see on the moon basically is what we see now. There were craters there before, but they might have been covered by lava, or they might have been kind of partly eroded by craters over the top of them. So we're interested in looking back in the past to find craters people haven't noticed before because they've been buried or smothered alive by other craters landing on top of them. So that's what we'll be doing it. We're going to use similar techniques to impact basins. That's taking images at sunrise and sunset to try and exaggerate the terrain with shadows and stuff to show these things up, or to simulate this virtually. We also want you to search through old literature, like the TLO from ALPO, BA journals, Astronomer, to try to find who originally found or mentioned buried basins, buried craters or impact basins, so we can give them the credit due that they were the discoverers of these. Now, we're only interested in unnamed ones because the named ones are already being used by lunar geologists and named by the IAU, so we're interested in expanding that and making this resource available to amateur astronomers and professional planetary scientists. So buried craters, the kind of things we're looking for. Now, this one is fairly well known. You can just about see it here. This is a visualization created on the LROC Quick Map website showing all ancient Newton. You can just about see it there. It's south of Plato, only really shows up at a shallow illumination angle. And it could even be, even though it's 115 kilometers across, it could even be that that's not a buried crater, but it just could be a couple of arcs of wrinkle ridges. But it's important to note these down so they can be investigated in future. Right, the ALPO BA program. So it's for astrophotographers and armchair astronomers when it's cloudy, or if you don't have a telescope. So the first thing we can easily do is to find the range of longitudes at lunar sunrise and sunset to see the basins listed in the catalogues, which I'll give you the web address to later. That's easily done. You can do it with LTVT, you can do it on Quick Map, you can do it by observing. We also want to map out, if you do see circular or arc-like structures, we'd like you to measure the longitudes and latitudes of a few of those and send them to me so I can put them into a spreadsheet for each of the basins, and then fit circles through those to try to get evidence that perhaps we have a multi-ring basin there, because there'd be a root 2 relationship for the radii and the diameters. You can also look for things using remote sensing data sets on NASA's LROC Quick Map website for circular structures and depressions. Obviously take images, looking for buried craters, and there's lots of other things you can do as well. And eventually, when we get enough of these basins, we're going to put them into a taxonomy, a bit like a butterfly collection, sort them into groups, like I guess you do with the different types of galaxies, a Hubble tuning fork type of thing. We'll see if we can do something similar like that with impact basins. There are about 100 basins listed, which may be true basins or suspected basins, but we'll have a go at that. Here's a quick look at the buried craters. If you go to this website here, you can click on that. And a lot of these have come off of this paper here by Evans, where they're looking at gravity data and thinking there should be a crater there, but we can't see it. So let's go out and see if we can find that crater for them. We may be unlucky, but let's give it a go. A lot of the columns are blank because we don't know the ages of these. We don't have the selenographic longitudes where you can see the things at sunrise and sunset. But we'll have this spreadsheet updated every month, and we'll just keep on looking and gradually fill out that, make it available to planetary scientists. Likewise, for impact basins, we have a similar thing over here. We have a type of basin, whether it's a peak ring or whatever, and we have a status, whether it's a probable basin, a known basin, suspected, or I've got no idea at the moment for some of these. So this will all hopefully be filled in. Right, the thing which got me onto this, apart from looking for impact basins at the Smithsonian, was on the morning of Christmas Eve last year, I went out, used a Questar telescope over my mother's, put a web camera on it. Not a terribly good evening for observing, but this is an area just west of Mare Nectaris. And look, this is on the day side of the moon. I didn't even know about this basin, but you can see it there. That's the Werner Airy Basin because it spans between two craters. It's 500 kilometers across. It's an ancient basin, obviously older than Nectaron there, just over here. So it's pre-Nectaron. And the lighting was just right to show it up. So I'm interested in pictures like this to find the selenographic longitudes to best see these basins. So another good place to look for basins is to go on the QuickMap website over there. You can vary the illumination, you can blend layers together for different remote sensing data sets and do all sorts of incredible things. The best thing you need to do is to go onto projections by clicking on that and find an area of the moon where you've got a suspected basin and just put it directly at the center of the disk. It's nice and circular. And then you can move on to the layers. Here's some of the layers. We've got overlays, Clementine data, Chandrayaan-1 data, Grail gravity data, Kaguya, that's Japanese data, Lunar Prospector, which had magnetic fields on it, Lunar Diviner, lots of things you can look at over there. You can even bring up chemical compositions as well. So be a little bit careful of this experimental layer that's crashed my web browser a few times using Mozilla Firefox. So just be warned over that. Just treat it with a bit of care. So let's have a look at some layers. Right, let's go into the Grail data. So one of the things we've got is a crustal thickness map, which you can color code. You can slide this to bring out the crustal thickness over there. This is Mare Orientale. This is the gravity data. You can see a bullseye effect there. And gravity gradient is interesting. That's where they differentiated. Look at the gradient of the gravity, and that shows up radial structures, or perhaps where there's lava tubes underneath the surface, very, very deep down, which might show up as circular structures. So all three of these can be used for finding evidence that might be a basin there. See, we've got another mascon over here. I don't know what that's all about. I've just noticed that. Maybe that's a large impact crater. I have to investigate. So yeah, use the Grail gravity data. That's a good way to look for basins. A lot of them will already be known about. You can check them against the list. By putting the cursor there, I can't show you at the moment, it'll tell you the longitude and the latitude. The other thing you can do is to look at the LOLA, that's the laser altimeter data. And here you have a digital elevation model. That's a topographic height map of the moon. White is high and dark is low. Again, you've got a slider. And there's Sinus Iridum. And this is an area just to the southwest. And look, we might have a buried crater or perhaps even a buried basin there. It's difficult to tell. You can look at the slope map. Again, you can slide the stuff around and that really brings out sharp changes in topography. So definitely there's an arc over here, which could be an ancient basin or crater. And the cleverest one of all, I think, is the azimuth, which is the direction of slope, whether it's north, south, east, or west. Which way is a steep, which way would you be climbing uphill? And that is really excellent. That is showing up an awful lot of detail, which you wouldn't otherwise see. I'm even seeing maybe a few buried craters underneath there. Again, I have to investigate, but they could also be due to wrinkle ridges. But this is really incredibly detailed. And I think even professional planetary geologists haven't twigged how useful this azimuth plot is yet. Right, magnetic data. As I said, some basins, on the opposite side of the moon to them, there's an antipodal point, and the part of the moon there gets magnetized. Lunar Prospector data, it didn't cover all the moon with magnetic measurements, but it shows in this area, which is almost antipodal to the Crisium impact basin, we've got some magnetized areas. If you look carefully at high resolution images, you can see the terrain there is somewhat different to what you would normally get with craters or emplacement of ejecta from basins. It's very looks like it's shaken quite a bit. So it could be the seismic waves went all the way around the moon and got focused onto the point opposite to the basin and really gave it a big moonquake there. I mean, literally throwing stuff up and down by a few hundred meters or something like that. And it also, if you heat stuff up and shake it, if there's a local magnetic field or plasma, you can magnetize the area. And that's what might have happened. Not all basins have antipodal points. The South Pole Aitken Basin, they haven't found one yet, as far as I'm aware. So I think Paul Spudis said that maybe somebody, I think it was Hood, said that they thought they had found something, but it's a bit iffy. The drawing tool is also useful. That's how you can send me the longitudes and the latitudes of points. So here is that area just southwest of Sinus Iridum, and you can use this drawing tool and just click on points where you can see the arcs. And when you finish, double click, and you can list out the coordinates and send that to me in an email. Just copy and paste it in. Tell me what area it is, and I'll investigate that. Okay, so just to summarize, I've explained what an impact basin is, different to a crater. It's planet-killing, almost a planet-killing kind of impact. I talked about its basic morphological characteristics, the landforms like the grooves thrown out by Everest-sized bits of rock flying across the landscape, scouring out valleys and things radially. I've talked about other evidence of basins, gravitational anomalies, magnetized antipodal areas, chaotic terrain, remnant sections of rings. I've shown ways to detect and measure basins and buried craters using shallow illumination, and particularly the azimuth slope plot on the LROC quick map tool. So now it's up to you. Take a look at my lists, which you can find when I put this online for you, or have a look at the TLO, and it's got the links to the web list in there. Have a look at those and see if you can detect these things, and send me your images. I'd be very interested to see what you can get. Have a look on the quick map tool as well, or LTVT, to see if you can find basins which are on the list or new ones you think you found. Then I can increase the list. You'll get the credit for detecting those basins if they are indeed basins. Also, go through past TLOs, BA journals, BA lunar section circulars, GELPO strolling astronomers. Again, looking for mentions, the very first mentions of buried craters, so that we can make sure that the astronomer who found that gets the credit for it and not some young upstart in recent times. Lastly, we have some useful references here if you're interested in impact basins. Hartman and Wood, 1971, Moon Origin Evolution Multi-Ring Basins. Click on that. It's a free book. It's worth doing. Wilhelm's The Geological History of the Moon's got a lot of stuff about basins. Again, click on that. It's a free book. Then Paul Spudis, Geology and Multi-Ring Impact Basins. You have to look for that on eBay, or if you want a new copy on Amazon, but that is another excellent book. Okay, so thank you for your attention. Are there any questions?
Tony, this is Richard Schmoody. Are you familiar with people taking images of the moon in thermal wavelengths like around 10 microns? I know we've had 2 or 3 papers in the last couple of years in the Strolling Astronomer on this. Have you used that to detect basins?
Yeah, I'm also into thermal imaging at 7.5 to 1 at 15 microns, and I also try it a little bit at in the shortwave infrared from 1 to 1.7 microns. There's excellent work being done by, is it Darrell Wilson?
I think it is Darrell Wilson.
Yeah, he's done some really great work. You do need a big telescope.
Yeah,
it works with an 8-inch, but the image quality is a bit iffy. So something like a 16-inch or an 18-inch would do much better for that. There are thermal images of the moon from the Lunar Reconnaissance Orbiter and other missions, which you can also utilize. I haven't really investigated using that data yet to look for basins, but it's something that I may look into. Thanks for mentioning it.
You're welcome, Tony. Very good talk.
Thank you.
Thank you, Tony. Thank you very much. Now you can get some sleep unless you've got your scope all set up and you're ready to jump outside.
Okay, thanks.
Okay. All right. At this time, we're going to bring back Mr. Schmoody, Richard Schmoody. And this time he's going to jump from whatever we did last time to Jupiter. As I said, for those of you who might have just joined us lately, Rich, he got his PhD in physical chemistry at Texas A&M University in '94. He is currently professor of chemistry at Gordon State College in Barnesville, Georgia, just southwest of Atlanta. And he is the coordinator of the Jupiter section, coordinator of the remote planet section. He's on the ALPO board of directors. He's an assistant coordinator in the Mars section for photometry. Now, this talk will be Jupiter in 2021. And in his description, he says that the 2 biggest events to take place on Jupiter in 2021 were the fading of the North Equatorial Belt and 2 bright flashes that occurred on September 13th and October 15th. The North Equatorial Belt had a mean width of 10.5 degrees latitude, for 1913 to 1991, but in August of 2021, it had a mean width of less than 1/5 of that amount. The drift rates of 46 features, along with the general appearance of that plane, will also be discussed. So you've got your 20 minutes or whatever, Richard. So let's see how you can do it.
Mute. Okay, thank you, Ken. Now, what I'm going to do is I'm going to give you a very small description. I believe in the United States, you can buy a box of chocolates about this big. Now, if you want the really big box of chocolates, you need to look at the reports that John Rogers has written about Jupiter. I think there's 9 of them. Count them on the BAA website, and he'll give you the whole thing. And a lot of very good work that him and his team have done. So I want to just focus on really 3 events and then just briefly summarize everything else. And so anyway, just an overview. First off, I want to make a few introductory remarks. That way I don't lose anybody right off the bat. Then I want to talk about the North Equatorial Belt. This is one of the 2 main belts on Jupiter. A lot of people, when they first look at Jupiter, they say, I can see the rings. Actually, those are not rings of Jupiter. They are huge equatorial belts. And in particular, the North Equatorial Belt has underwent a lot of change. And so I want to talk about that. And then I want to talk about the bright flashes that were observed last September and October. And of course, this brings up to about 10 such events since 2009. Then I want to talk about the Great Red Spot. Apparently, it showed an interesting feature. Now, maybe just because we're getting sharper and sharper images, or there may actually be some real changes going on here. And so, again, I'm going to focus on these 3 changes, and then, there's much more. And again, like I said, there's some really great reports that have been put out by John Rogers and his team on the BAA website. All right. Well, in the next slide, this is just a picture of Jupiter. South is at the top. And if you look at the very center of Jupiter, just go just about, half an inch down or a centimeter down, you'll see a thin brown band. That is what remains of the North Equatorial Belt. And this is the very southern portion of that belt. So all the rest of the North Equatorial Belt, about 80% of it, has faded or has completely gone away. And I find this very interesting. I've been kind of keeping track of the North Equatorial Belt since the mid-1990s. And I believe this is the thinnest it has been. So again, I think in 2022, it's starting to get wider. So again, keep an eye on Jupiter there. It's one thing about Jupiter is always changing. And another interesting thing associated with the North Equatorial Belt are these little brown spots, dark brown, that are just below the narrow North Equatorial Belt. Now, the next slide shows how the North Equatorial Belt has changed. And I've got the white arrow showing the North Equatorial Belt. Of course, back in, actually, that should be 2017. Oops, that's not 2007. I'm pretty sure that's 2017. About 5 years ago, North Equatorial Belt was very wide. Okay. And then about 8 years ago, it was kind of in the middle, sort of thinner than normal. And then, of course, just about 11 months ago, you can see how thin it is. Our very own Frank Maleo took this picture. And again, so the width of the North Equatorial Belt has changed quite a bit. Of course, one interesting thing on the side is the equatorial zone has actually darkened. It's darker in 2021 than was, say, 8 years ago in 2014. So again, it's interesting. It almost seems like with one gets brighter, the other gets dimmer. So it'd be interesting to look and see if there's any kind of a relationship between the equatorial zone and the North Equatorial Belt. And so, okay. So again, the North Equatorial Belt, in summary, very interesting feature. And it seems to go through a cyclic change. It will get wide and then it will start to narrow. It gets narrow and then you'll get some spots that occur on it, and then it'll turn back to wide again. And again, this is kind of about every 3 to 5 years that undergoes this cyclic change. Right now, bright flashes. The good thing about modern technology is we can actually determine not only the location of these features, but also how long they occur. Because again, there's several things that could cause a bright flash. We can have a cosmic ray strike. We can have some other kind of event, maybe, I don't know, a tumbling satellite, who knows. But by monitoring how long these flashes are and how they peak in brightness and then come back down, we can kind of rule out some of these other factors that might cause them. And the general consensus is what we're seeing is a large object burning up in Jupiter's atmosphere, similar to what we had in Chelyabinsk, Russia, back in 2013. And of course, we have studied the Chelyabinsk event quite a bit. We know that it reached a brightness brighter than the sun. And we're pretty sure that it had a diameter of something on the order of 18 meters, or about 60 feet. So again, that's a very good sign there. And so just some quick facts here in the next slide. All right, the September 13th, we had a flash on September 13th, and the approximate time was right here. 9 people either observed or imaged this event. So this is a record. The brightness was estimated to be around magnitude 4. And if you go back and look through the math and of course scale it to the Chelyabinsk event, and I talk about this in one of my Jupiter papers, I believe it's published in 2020, come up with an impactor size of about 15 meters. Now, of course, that's assuming that the impact produced the same fraction of light that the Chelyabinsk event produced. And again, you're comparing Jupiter to the Earth, so again, that might not be the best assumption. And of course, J. Pereira of Brazil is the first person who discovered this event. But again, like I said, 9 people observed this. Okay, so that's a record, either observed or imaged it. And again, special mention to Mark Delcroix, who's got some imaging processing software that actually can look for images of flashes. And again, it takes, some people will take a video for 10 minutes and they've got hundreds or maybe thousands of images. And just in maybe 10 of them, you can see a bright spot. Of course, we can kind of rule out cosmic ray strikes or things like that. A second event happened just over a month later in October. And again, 3 observers saw that. And again, brightness estimated to be around magnitude 4. And again, the size, something like 15 meters or about 50 or so feet across, something about the size of a very large house. And again, Ko Aramatsu of Japan is the discoverer of this. Now, what I've done is I've done a couple of things. First off, how many people have seen a shooting star? Raise your hand. Shooting star, meteor. Okay. What's happening is you have an object, say, as big as this eraser, and it's moving so fast, moving at supersonic speeds, that it burns up. Now, part of the energy, this meteoroid has huge amounts of kinetic energy. A small fraction of that is converted into light. And that's what we are imaging here, is that fraction is turning into light. Something on the order of, I think it's like 1% of the kinetic energy. All right, that's the first thing. The second thing is the brightness, how bright it gets. It's going to be proportional to the size of the object. But of course, it's also other factors like the velocity. In the case of Jupiter, the objects are moving faster than they are for the Earth. So again, the scaling, it's kind of a little iffy. Now, the other thing is I looked back at 2009. How many people saw the image of the dark spot that I think was Anthony Wesley over in Australia imaged? It's back in 2009. It's a dark spot on Jupiter. Very good. Well, professional astronomers have estimated the size of that object to be about 500 meters, which is about a third of a mile. So I've taken that size, looked at the size of the impact scar, and it's roughly a ratio of 1 to 10,000. So in other words, if you have a 1 meter object hitting Jupiter, you're going to get a 15-kilometer size spot. That's what I reason. Of course, when you look at 15 meters, you're going to get something on the order of 200 kilometers. So again, that's too small to image from the Earth. I am not sure about Juno because the October 15th event just so happened to happen in a place where one of the Juno perigeles happened, and there was no reported dark spot there. Maybe, I think John Rogers mentions that in one of his reports. So again, it would be interesting to know the exact resolution of the Juno image at that point where this happened. So again, remember that about a 1 to 10,000 ratio. That's what I found, at least for the 2009 event. All right. Now, in the next slide, the Great Red Spot always seems to be doing something unusual. And of course, back in I believe it's 2020, parts of it were breaking away, flaking off. In 2021, it had sort of this dark ring around it. And of course, that's not so unusual. And it's apparently shrinking gradually. And in 2020, it actually shrunk quite a bit and then kind of regained some of its size. Of course, that's what I was able to measure. Of course, that's also discussed in the BAA reports as well that are online. But this is what I find really interesting. Look at the image on the right. The big white oval is the Great Red Spot. What do you see inside? Anyone can unmute. What do you see on the inside? Anyone?
Dark spot.
Yes, a dark ring. Exactly. Very good. This is something unusual. And again, now, is it due to something changing, or is it due to the fact that we're just getting sharper and sharper images because camera technology is improving? Let's keep an eye on this. Now, of course, if you look at some of my previous Jupiter reports, you'll notice that I notice a similar dark ring in visible light images in oval BA. So again, it would be interesting to see what is going on here. Possibly this dark area in the Great Red Spot is due to some kind of low trough within oval BA, the Great Red Spot, because again, the Great Red Spot appears white because it's at a very high altitude. Okay, and of course there may be some troughs that correspond to that darker ring inside. So just stay tuned. Now, fortunately, and again, I'm just using images from the ALPO website to get drift rates. I've been able to track 46 features. I think the most interesting feature would be one in the South Polar region, around 60 degrees, and it changed drift rate. It was moving at one speed, and then at some point it changed. Okay, it's just like a car going one direction, all of a sudden it goes in reverse. Okay, something like that. And of course, the best explanation I have for this is that the latitude changed it by something on the order of 2 degrees. So again, something may be pushing these spots into a higher or lower latitude. And of course, they go at a slower rate. So anyway, so again, so just in summary on the Great Red Spot, it's surrounded by a brown ring in RGB images or color images. But there's a dark ring inside the Great Red Spot in methane band images. And again, I believe there's some correlation with the near infrared. I'll have to look at that a little bit more. Another interesting thing about the Great Red Spot, and of course, this has been mentioned before. I know John Rogers did a big paper on this about 12 or 14 years ago. The Great Red Spot, it doesn't move at a constant speed. Okay, imagine you're on the interstate. Okay, and you're following a car at a safe distance. You're going 55, or let's say 70. Car goes 73, and then 72, 71, 70, 69, 68. Then it picks up speed, 69, 70, 71, 72, and 71, 70, 69, 68. You can just kind of see the car moving closer and farther from you. You've got your car on cruise control at 70. So this is essentially what the Great Red Spot is doing. And of course, like I said, I believe John Rogers wrote a very good paper back, I think 2008 on this, a very excellent paper. Highly recommend you look at it. But Great Red Spot's still doing this. All right. So, and again, let me show you one more picture. No, next slide, not previous, next slide. Okay, and again, you can see the longitude plotted on the vertical axis versus the days after February 28th. And again, you can see sort of the slowing down, speeding up, slowing down, a little bit of oscillation above and below the line. And of course, the slope of the line just shows the mean drift rate. All right, so in conclusion, okay, next slide. First off, very big highlight. We have a very narrow north equatorial belt. I believe it's getting a little wider in 2022, but again, I haven't really examined the 2022 images yet. Two very bright flashes. And by the way, one thing I do want to say on the bright flashes, there is a chance that more flashes occur when Jupiter is at a certain point in its orbit. And that certain point is about right now. About every 12 years, it goes through maybe a little bit more. We had a little flurry of them back in 2009, 2010. Of course, add 12 years to that, we're now today, okay? And again, in about 2034, there will be, again, possibly more flashes than normal. It'll be interesting to see if this is true or not. Then finally, Great Red Spot surrounded by a dark border. And there's a dark ring inside of it in methane band images. And of course, I'd like to thank you for your attention. And if you have any questions, I'll be willing to answer them or try to answer them.
Yeah, it's Rich. Yeah, that's very interesting talk. I just two things. I just texted the chat that you actually see my image of Jupiter Great Red Spot taken in 1988 and compared to last year. You can actually see it's a lot smaller.
Yes.
You know, yeah, it's a lot smaller. Then not only that, I compared other years. I can actually see it getting smaller, smaller, smaller.
Yes.
And I don't know if it's still going to get smaller yet, or maybe it's a certain size that probably is contracting or expanding or contracting. But over the years, it's see what's going to happen. Yeah. So secondly, you mentioned that Jupiter is closest to perihelion point, closest point to the sun in orbit. Does that mean because it's close to the asteroid belt?
You know, that's an interesting thought. I didn't think of that. And you may have just hit the nail on the head there. That is a possibility because right now, September, October oppositions are when Jupiter is at near perihelion. I believe it's October. And of course, we're approaching that now. It's going to be opposition, I believe, in September, the middle of September, around that for 2022. So this may be the time to really look at that. Very good, Frank. That's a very good suggestion.
Now, John Rogers, go on. You're on mute.
Okay, yeah, sorry. Thanks for a great talk, Richard. I wondered if the ALPO or any other group in the US has any dedicated program for surveying for Jovian impacts for these flashes.
Unfortunately, I'm not sure we do. I know Mark Delcroix is, he's probably the one leading the pack on that as far as I know. I mean, I may be wrong in that, but he's got the software. I am certainly not doing anything myself. I know that. I'm just kind of trying to do other things, but it would be good if we did. But again, unfortunately, I'm not sure, I've looked at people imaging. It's dominated by people from Europe and Japan. A lot of people from those two countries.
It would be great to have more from the US,
I
particularly the West. We don't seem to have any contributors to international databases from California, and there must be observers in California.
Yeah,
but but with regard to the impact, you're quite right. Mark Delcroix has this software called Detect, and you don't actually need to be part of a group because everyone is really urged. Everyone who's imaging is urged to download that software and run all their videos through it.
Yes.
It can be done overnight, and then send him the results. Not only positive detection, but also negative detections.
Yes.
One of the important things is to get an estimate of the frequency.
That's
Auto Staggered 4. If you look at Emil Krikant's YouTube video, he has that program included in Auto Staggered 4, so it should check for flashes while you're aligning and stacking and give you possible matches. It isn't out yet, but that's the hope. So that should be interesting.
That'll be great.
Yes.
Mark's team actually, an observer using Mark's program actually discovered an impact retrospectively during the past year. They discovered one that had happened, I think, in 2020. That hadn't been reported until recently.
Oh my, I didn't even know that. Well, very good, yes.
Rich, I find this amazing. During the last 25 years, we have seen bright flashes on Jupiter. But what about in the past, like maybe 50, 100, 150 years ago? Are there anybody witnessed something like that?
The only thing I can think of, I'm not sure if anyone has witnessed them. And again, they only last about maybe 2-3 seconds. And unfortunately, you have to confirm it, really. But I believe it was Rick Hill, who may be attending here, wrote a paper about a possible Jupiter impact happening back, I think, in the 17th century. Correct me, Rick, if I'm mistaken. But, and again, it sort of developed the same way that, of course, the 1994 events happened. That's the only paper I know of.
No, mine covered 19th century. I used BAA references.
Okay, 19th. Okay.
Okay, well, at this point, we're going to move along. Good job, Richard.
Thank you, Ken.
Very, very good job. And to wrap up the afternoon, guess who? Mr. Tim Robertson. Tim lives in Simi Valley, California, near Los Angeles. He works for the Goddard Space Flight Center on the JPSS Weather Satellite Program. He's been a member of the ALPO since the early 1970s. He sits on the board of directors, and he is responsible for the ALPO outreach section, and is also the host of the very popular Observer's Notebook podcast. And Tim also has an asteroid for him, Tim Robertson 5718. Speaking of the podcast, if any of you have not been asked to be on the podcast, you soon will be, I'm sure. So take it away, Tim.
Thanks a lot, Ken. I will try to get a lot more of you on the podcast. I've had a lot of fun doing the 75th anniversary member podcast as well. First thing I'm going to talk about today is something that I was actually a student in back in the 70s when I joined the ALPO, the training program. I was involved with it for a few years. I made over 200 observations of the crater Eratosthenes, and I finally was able to graduate from the program. That took some time, but I was so impressed by what I learned during that time in the program, that when the opportunity arose, both Matt Will and I actually took over the program and cleaned it up and made it what it is today. And we're pretty proud of how the program works. It's open to any member of the ALPO. You have to be a member, but beginners or experts. And the goal is to make you a better observer. And, we all have telescopes. We all look to the telescopes. Some of us only put cameras on the telescope. There is no imaging at all in the training program. Everything is 100% visual. We've all been to star parties where you put a galaxy in the eyepiece and you look in the eyepiece and you see the galaxy, and then some woman comes up and looks through your eyepiece, or some man comes up, looks in the eyepiece, and you say, okay, that's a spiral arm galaxy. And they look at you and say, I don't see anything. Well, why do you see it and they don't? Because you have trained your eye to see certain details through the eyepiece. And that's exactly what we do within the training program. I don't judge students based upon their artistic ability. I judge them based upon the accuracy of what they draw. That's really more important than anything. You look at this drawing, of Jupiter, Carl Russell did this years ago in the training program. It's not pretty, but it's accurate. And that's what I really, really care about in this. And the ALPO revolves around submissions of astronomical observations from all of our members. And the more consistent and accurate they are, the better for the organization. And the program is set up in 2 tiers. Basic tier includes, we have a novice observer's handbook that both Matt and I wrote. It talks about the fundamental skills such as making drawings and how to submit observational data, learning how to calculate scene, transparency, universal time, all the basics, but it's all involved within the program. And then when they can successfully demonstrate these skills, then they advance to the novice level, where they focus on one special area of study. It could be the moon, it could be Jupiter, it could be craters, or anything visual like that. And the nice thing is there's no time limit to complete the training program. I don't bother the students to send me observations. I know everybody's got lives that they deal with. So I've had some students take 3 years. I've had one student take 6 months. I think that was David Tusky, who's on here. He went through the program really quick. But it all depends on how motivated you are and how much time you have to give to it. There's no minimum telescope requirement. I went through it in the 70s with a 60mm refractor. Once a student has mastered everything, they're then certified to be an observer in that particular field. Next thing I want to talk about is the Observer's Notebook podcast. Started this back in 2017. Matt Will was my first victim on that. We did about a 20-minute conversation about the history of the ALPO. And I got to tell you, it's my first podcast I've ever done. I listened to quite a few of them, but first time you hit upload and you look at it on the internet and where anybody in the world can listen to it, and days go by and no one has listened to it. Well, our very first month, we ended up with 25 downloads, and I was thrilled. And I can actually look on the site to see where they're coming from. And they were from all over the world. I was shocked by that. Today, we have about 150 episodes online, and we average about 115 downloads every single day. So there's people out there listening to it. We release a new episode on the 1st and 15th of each month. The latest episode we have is a 75th member profile I did with Bob Garfinkel of the ALPO. He's been the book reviewer and a member of the ALPO for many, many years. It's a great conversation. And I just recorded one, I think it was last week, with Bob Lunsford, who's our meteor guy, who comes on the podcast probably 5 or 6 times a year. He should actually co-host the podcast sometimes, I think, because he does a really well job. And he's going to be talking about some upcoming summer meteor showers. Like I said, we have listeners all over the globe. Most of them are in the US, but the UK, Canada, Costa Rica, Ireland, Germany. I mean, I am really... for my little tiny podcast that we do here, I am very pleased to see that it's got worldwide attention. And it's also available in every format. If you've got iTunes, you can listen on that. Stitcher, SoundCloud, Google Play, iHeartRadio. If you have that Amazon Echo thing in your house that listens to everything you say, you can tell it, hey, play me the Observer's Notebook podcast, and it will play it for you. So it's all there. And it's also on the YouTube channel. A lot of the podcasts I have converted over to YouTube. So now they're in audio format only. So you can listen to them also on YouTube. And if you don't have a smartphone, you can go to this website here, soundcloud.com/observers notebook. And that's where they're all housed, in that one spot. And I don't know how many of you listen to podcasts or if you've ever done it. To subscribe to them, it's really simple. All you need is your cell phone. And on your cell phone, there's a little icon, this thing right here. You click on that, it comes up with a search bar. You type in Observer's Notebook. You click on the logo, you hit subscribe, and boom, you're done. Every single time I upload a brand new podcast, it comes right to your phone, and all you have to do is hit play and listen to them. And they're not, the longest podcast I have is about 90 minutes. The shortest is about 15, and they all average 35 to 45 minutes. So it's well within your commuting time. And that's when I listen to my podcasts, when I'm in the car, because it's just a lot easier that way. But that's an easy way to do it. You subscribe once, and anytime I upload a new episode, you get it. And what subjects are we discussing? Well, like I mentioned, the longest one we ever had was 90 minutes, and it was a history of amateur astronomy in the US. Also, I've done individual section biographies with all of the ALPO section coordinators. Don Mackles, I think he's online here. He talked about discovering comets, and Don also has his own podcast. It's really good. Talking about the training program, I had podcasts on that. Basics of planetary imaging. Rick Hill came on and talked about that. Comets of 2021. Our comets podcast are some of our most popular, and that's Carl comes on every January and tells us what great, awesome comets we have coming for that particular year and how they're just going to light up the night sky. Okay. And then we also have the 75th anniversary member profiles that we've been doing recently. And those have been a lot of fun. I'm talking to some of my past heroes in amateur astronomy of that. So it's kind of cool to be doing that. The podcast, it costs money to put online. We have all sorts of services. So I mentioned Spreaker and Google Play. It's not free to put the podcast out on those different things, and also the software that I need to develop the podcast and clean it up and get it available to go online. So I use a thing called Patreon, and I have a number of Patreon supporters here on this talk as well. We have 4 different levels of Patreon. You can give $1 a month, you can give $10 a month, you can give $20 a month, or we have 2 subscribers that actually give us $35 a month for support of the podcast, and that they also become producers on the podcast, and they also get a year's membership to the ALPO. So this is how it's paid for. It's not free. We're still in the red a little bit from 2017, but we're still working through it with the Patreon. I couldn't do it without their support. I really, really couldn't. I'm going to retire this year, so I really couldn't do it. The next thing, one of the most recent things we came up with was the ALPO YouTube channel. This is right now we have 16 people watching on YouTube. I want to thank everybody over there for doing that. And if you see that little thumbs up button in front of you, hit that. That brings more people to the podcast. And also, I would really like everyone to subscribe to the YouTube channel. The more people that subscribe, the more the YouTube algorithm throws the ALPO out there when people search for planets or telescopes or astronomy, and it brings more people to our organization through this venue. It's amazing. I'm pretty close to the same amount of downloads of the podcast on the YouTube channel now than I get on the YouTube that I do on SoundCloud. So it's pretty interesting. But there's also changes I want to make with the YouTube channel. It has the last 2 conferences available on it. So if you want to go watch our last 2 conferences, they are available completely online. We will also have planned to have future live stream events of astronomical events. Last year for International Sunday, I had Pam Shivik and her husband, Randy, come on, and we did an hour-long solar observing, looking at the events going on the sun and things like that live. If you have the ability to do a live event, if you have a camera, you want to set it up, you want to set Jupiter some night, let me know. And we can do an impromptu live event on our YouTube channel. It's simple to set up. If you are on here right now on Zoom, you attach your camera to your computer and you share that screen. It's that simple. So we can do that anytime. And that's something I really want to do. Also, I want to put training content online. If you have a astronomy training program or a class that you've taught, record it, and we can put it online as well. Okay. What I really want to do, I want video content creators. If someone out there can make videos on anything amateur astronomer related, let me know, because we want to really start utilizing this channel to bring more people in to the organization. The more people, more eyes we get on the YouTube channel, because YouTube is huge. I don't know if you've ever gone down YouTube rabbit holes at home when you're search for something and you end up looking at, you know, bunny rabbits in the desert or whatever. It's just, yeah, it's crazy. So I really want to grow the YouTube channel. I really do, but I can't do it by myself. See, I've got a lot of balls in the air right now as it is. So if you are interested in doing some video content, we'll help you out with the Patreon money that comes in. If you need some use your phone for video taping. I mean, that's all you need. You don't need anything special. So think about it. If you want to help out with YouTube channels, please let me know. Oops, sorry about that. Where'd it go? Yeah, there it is. Okay. The youth section. Okay, the youth section is coordinated by Pamela Shivik. She's been doing that for 3 or 4 years now, and currently it is only a group on Facebook. And what she's done, she's laid the groundwork for where we want to go. She's contacted a lot of youth organizations, astronomy clubs, things like that, to join her Facebook group. Now, in the near future, we want to set up online observing programs for kids. What I'm looking at is something very similar to what the Astronomical League has. They have certificates for small programs, looking at the moon phases and things like that. That's what I would like to have in our youth section. Kids, things that they don't need telescopes for. They draw the moon phase through an entire month or a few weeks. They send it to the ALPO, and we give them a little certificate. We want to publish their observations in the journal. So we might have just a youth section page every month or every issue where we talk about observations from the kids. I'd also like to come up with a youth membership level for kids to join or schools to join the ALPO as well. So I would really want to open up, because you look on this channel and everybody's got gray hair. Everybody looks like, me. Can you guys see my screen? Hello?
I'm not seeing what you're sharing.
Okay, now can you?
Now, yes.
Okay, I'm sorry. Somebody should have said something. I was like, no one's. Yeah, I'm looking at the YouTube page and I don't see it. I'm like, oops. Okay. So now you see it, right? Yes.
Affirmative.
Okay.
Yes.
Thank you. All right. Appreciate it. Okay, so this is just a list of the things I've already mentioned of what we want to do, but we want to all start interacting with the school programs and scout programs as well. So if you have contacts with those types of things, let us know. I mean, Pam and I are more than open to have assistance in this, because this is the only way we're going to grow the ALPO. I mean, I look at the faces of the people on the side of my screen, and if they do have hair, it's white. So it's like we want to start promoting, the youth to really get involved with our organization. And here's my contact information: commentman@commentman.net. It's my email. We have a Twitter page for the Observers Notebook. It's observers at Observers NB Pod. We have a Facebook group for the Observers Notebook. Just look for Observers Notebook. The ALPO also has a Facebook page. Just search for ALPO Astronomy. There's our website. And the ALPO also has a Twitter page. ALPO Astronomy. And anybody have any questions?
Don't look at the hair. Just keep staring at the mustache.
Yeah. It's hard to miss, Rick. Okay, now, no questions? Yes, sorry, Richard.
Just I guess a comment. I'm willing to do a podcast for you on Jupiter coming up in 2022. I believe it's going to be at Oppositions September 15th, something like that. So
I have you penciled in for a few weeks from now. I will get.
Okay.
I will get with you.
Okay.
Yeah, and Julius with Saturn and Venus. Yeah, so we're gonna. You're all penciled in on my upcoming schedule. And if any of you have a topic that you want to talk about for the podcast, please let me know. Please. Now, I think Ken, you want to say a few words?
Yes.
Okay. All yours.
I'm going to. I just wanted to remind all of you who are online. This is just going to be a really short recap on the last couple of issues of the ALPO Journal. If you are an ALPO member, you automatically get the PDF, or you get notification of the PDF version, which is in full color. And as we talked about way earlier, those who get the hard copy, it's black and white on the inside, but full color on the outside. But the thing is that all issues of the journal are available online, with the exception of about the last year's worth, because the way I look at it is besides the training program, the one thing that you can hold in your hands or pull up on the screen consistently is the ALPO Journal. That is the voice of the organization. And I believe that that is a benefit of membership, and to make it free for everybody at all times, no matter what, why pay dues? This is your dues, in action. So I just wanted to show you just a few little bits about the last couple issues of the journal, because what we do is when we get ready to distribute it, we send out a notice through MailChimp, and you'll get a notification that says to click on this link, and then you key in your membership number and your email address, and then you'll be able to just download the journal. Well, I remember going back to look at the stats, the statistics that MailChimp has to how many people actually download the announcement, and how many people actually click on the link in the announcement to look at the journal, and it is phenomenally low. So I'm talking about maybe 25% of people actually look at the journal, and that's kind of disheartening, but we do it anyway. But for those of you who wonder what it looks like, let's see if I can share my screen here. I'm trying. Share screen. Is that coming up? There. How's that? Anybody? Okay, good. This is I've only got these few issues, but this was the issue that came out last December, and it was 128 pages. We are well past the page count of Sky and Telescope magazine. This was the cover. It didn't come out as well as I wanted it to, but this cover image was image of the Pleiades with the almost total lunar eclipse of last winter. And this is a write of bullet points about what was in that journal, a roundup of everything, a book review by Jamie Jenkins, a report by Jim Tomney on the ALPO website redesign, a member profile about Bob Garfinkel. Rick Hill consistently does a really great job on Carrington rotations. This issue had a Venus app report. There was something on lunar dome studies. We do that at least twice a year by Raffaele Olena in Italy. David Teskey did a short paper on something, and then of course Julius Benton. Let's see now here. Okay, the spring issue was where we introduced our new logo, the color logo, stating our 75th anniversary, and a little whimsical cover of all of our friends in the solar system. And again, a roundup of general news and obituary on the sad passing of longtime member and executive director Harry Jameson, who spent his last years out in Wyoming, where they really have some great skies. And as you see here, a lot of other stuff. Now, this issue was 100 pages, which used to be considered a lot. And let's see, here we go. This was the summer issue, down to again 100 pages. And although it doesn't show that well here, this was taken this past spring with Jupiter, well, the moon, Jupiter, Venus, Mars, and Saturn in the early morning sky. And so this is a lot of stuff. And a preview, this is what we've got going. This issue is in progress. So this is what the front cover will be. I don't think it was from anybody's backyard, do you? It was one of the images from the Webb Space Telescope. And this is what it looks like we're going to have: a point of view column, a general roundup. Carl Hergenrother does a great thing on a look back on 75, 50, and 25 years worth of stuff. A member profile. We'll have news on this conference. Rick Hill on Carrington rotate. Well, this one is something by Theo Ramakers on cycle 25, solar cycle 25. Rick Hill's going to do something on Carrington rotation 2248 through whatever. I'm not sure if it'll be through 49 or 50. A Venus app, a short write-up on the Euclides crater by Robert Hayes, who has no computer. He does these things purely visually and sketches them and sends them into David Testi, our lunar section, let's call reporter. We got a thing by Rich Schmoot, and this is by Jim Melka, a bright dust storm in the southern hemisphere of Mars. Rich Schmooty's Jupiter app report, and then Julius Benton's Saturn report. And finally, yes, finally, I'd like to walk you through I want to get rid of, well, I don't know how I can do it. I want to show all of you how to, well, on the right-hand side here, I want to get rid of that. Okay. Anybody who wants to get a to get any issues of the old journal, all the way back to one, at the upper right corner, you will click on section galleries. And here's your icons. You'll go to.
You're not sharing that screen.
I'm not. Okay, let's see. It says I am sharing. Well, it's always something. Well, you share. Let me see. How's that? Is that coming through? Yes?
Yep, we got it.
Okay. I'm going to go to a different couple screens here, so let me know. When you're at the home page and you clicked on section galleries, that'll take you to this screen. And here's your icon for publication section. Now, am I still sharing?
Yes.
Okay. This is what we have it organized here, ALPO journals. And the first icon is indexes to all of the journals with the last few years yet to be done. And here we are. I have this through issue 1 and issue 2 of volume 64, which I just showed you. But this on my particular platform, this is a 2-screen thing. So I would go to the next screen if I can do that. Well, in any case, next. And this takes you all the way. This is my second screen, and this here is volume 1 of the Strolling Astronomer, all the way back to issue number 1, which was March of 1947. Now, in my particular platform, rather than display, it downloads to my terminal. But I just wanted to show you that. So, you know, you've got a lot going for you as members of the ALPO. The journal, I do the best I can for you with the journal, and I look for contributions from any and all of you. And don't feel that just because you see apparition reports that you have nothing to contribute. Jim Milka does some good work, and like I said, Robert Hayes contributes, and so I'm looking for anything anybody can send. And it may not be in the very next issue, but it will, if it's written correctly, we will put it in front of the section coordinator for his or her review, and we will publish it in our journal. So at this time, I'm going to turn it back to Tim.
Thank you.
Welcome. Okay. Tim, you're muted.
Okay. Thank you. All right. Well, that'll do it for today's schedule of conference. Here is tomorrow's. We're going to start again at 10 o'clock tomorrow. For those ALPO board members and staff members, our board meeting will be held in approximately 2 hours, 4 o'clock Pacific, 7 o'clock Eastern. If you're on the board, your invitation will be sent out. Your Zoom link will be sent out in about 15 minutes. So look for that. If you're a member and you'd like to attend the board meeting, send me a quick email at commentman@commentman.net, and I will add you to that distribution, but send it to me within the next 5-10 minutes. Otherwise, you won't get one. All right. Other than that, if we don't have any questions for today, I really want to thank all the participants that joined us today. Let me see what we got here. We have currently 32 on Zoom and 21 on YouTube. So I want to thank the YouTube people for really joining in and being a part of this. I tried to get to all your questions. We've actually picked up some new subscribers as well. So thank you for that. I'd like everybody to head over there and subscribe to the YouTube page too. It really helps us out. But anybody have any questions or final statements before we close it out for the day?
Booyah.
Booyah. All right. All right.
Tim, one thing, you're going to send out the link for tomorrow's talk, right, tonight?
I will send it out tonight.
Okay.
Tomorrow's Zoom schedule will be sent out in a couple hours.
Yeah, okay.
All right, just like I did today. So, and then the Zoom link for the board meeting is going to go out in a few minutes. All right. I want to thank everybody for being online today. We'll see you all tomorrow.
Bye-bye.
Good work.
Thank you.